hello everyone. Jack the Generalist is here. Thank y'all for clicking on this, for watching this, and for supporting me. I appreciate all the follows and all the subscriptions you've been giving me. My YouTube channel have grown from 70 subscribers to 191 by now. So things are going really well. I would say for my own, my own view for now. Still more is coming. More shorts and more TikTok type of videos are to come. More reels, and we will be also multi-streaming on different platform. Let's see how that will work. Still need to set it up. Might do it on Saturday. All right, what are we doing? What the hell are we doing? All right, good question. What we're doing is that we are streaming our learning process in DoubleJump Academy's workshop Houdini for Games, made by DoubleJump Academy and in cooperation with Grayson. Grayson is the mentor. He works at Naughty Dog as a technical artist, and we are building that cool bridge in Houdini, where it's procedural, where we can create it on the go. If you are curious how that looks, check out the other videos I've uploaded or the other streams from before, but you will probably most likely see it here as well. So today we'll be creating a lot of simulations. So the point is you would be able to create the bridge in Unreal and click a button where it should simulate the gravity and other stuff too. Cool. Yeah. Thanks for joining on the stream as well. Those who joined the stream, my heart to you. Thank you so much. And yeah, let's keep it going. First, we need to get back to where we were. And that was, we were working with our Vellum here. Let's just view what we were doing. So let's go step by step into our last thing that we've been doing. Yeah, well, we packed the geometry. It's not separated geometry anymore, and we made sure that our index is still working. Our index is the attribute we worked with to separate the planks, so we are able to create different UVs on different... so that we basically are shifting the UVs, and we did that with enumerate. Check day 12 if you want to know how that works. All right, so the next step is that we added volume constraints grain. All what you need to know for now is the word grain. Grain had given us the ability to add, if I press W, I will go back from wireframe to the actual geometry. Boom. So basically it took the borders or the volume of our planks, which looked like this, by the way, and spread, let's say, particles inside of it. And we decided what type of size they are, for how are they allowed to be, what's the minimum size of it, what is the maximum radius of those spheres, and what type of thing that we want to fill, because you could choose regular grid and it will look differently. We explored that in day 13, sorry. Okay, so let's also check what we have changed in that node. So let's just make this a little bigger for you all to see. What we also had changed is our point count to, yeah, this one stayed, but we also changed the particle size to something lower. Let's check what we've done in the physical attribute. We have definitely chosen define pieces, and we chose from connectivity, which I still don't know what it means to 100%, honestly. I'm just basically following what's happening, but we could read about it. Define pieces, parameter piece mode. Split the object into disjoint pieces when generating particles. Split the object into disjoint pieces. Would that mean that they will crash? We will see. From connectivity, there's not really much here to read from. And then we enable transfer piece attribute, which had created our piece attribute that we use in the next one. We'll go over this later. By the way, this Vellum constraint is super complex node in my opinion. It has so many options, and I'm still trying to understand those complex options. I'm gonna pause the recording because I need to sneeze. Good. So where were we? Sorry. Yeah, I was talking about the Vellum constraints and that it was a complex node, and I still need to understand exactly what it does. I mean, it depends on the usage, right? Because we use it here to make a simulation out of the ropes, and we have used it in different ways right there. One to split the rail walls, one to split the upper rails, the lower rails, and we're able to basically choose how stretchy things are. Yeah, but it is still a bit complex for me to understand. Anyway, so yeah, we were here and we said we have transferred our piece attribute, and if I look at it and read, when defined pieces is enabled, output the source piece attribute to each generated particle. So basically it had created a piece attribute, which we see, let's see, mass piece right there. It has a value between 0 and 18. Why 18 though? So let's check our planks if they are 18 planks in general. All right, so we will start counting. Thank God they are a bit different. So 1, 2, 3, 4, 5, 6. All right, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 makes sense with the 0. It's 19 pieces because it starts from 0. And if you start from 0, there are 19 pieces. Cool. So basically, when we've enabled transfer piece attribute, we have created an attribute called piece, and it had grouped each and every plank into an attribute and called it piece. All right. So, and in our Vellum constraint, we have chosen group type point, and we have chosen define pieces, and we chose from attributes and piece. All right, so we were able to define the pieces here to read the piece attribute from here, from the Vellum constraint grain. And what else did we do? We didn't touch the stretch. We didn't touch here. That is all what we've done here. And we've also added constraint type shape match. Let's see what that does. If I read just constraint type, parameter constraint type, the type of constraint to generate, this affects, okay, so this affects the visibility of many of other parameters. Usually this is set by using the appropriate tab macro. Okay, so we still don't know what the shape match does. Let me check. All right, but we wrote some stuff last time that is basically explaining what the shape match does. I just need to get my notebook then. I'll be right back. So let's read it. I found the papers and I'll just read it. Vellum shape matching. That is the workflow or the technique we're using right now. And it basically creates a vellum grain of our plank pieces. We did that. Those are our vellum grain. We use the grain for our simulation. We have established that because actually it falls down. If we check it, if we click here and play, let's see, and click again. We have to view it, sorry. Okay, let's go back. Yep. There is a simulation which works. Okay, so we are using the grains that we created to do the simulation. Then we can use the whatever we created so far to transform the grain translations in the world from simulation into pieces. Okay, so we'll check what that means in a bit, but I bet it means that we needed the pieces, we needed the grain in order to continue simulation, and we need now, once we're done, to take the translation that are happening in the animation, But let's see how that means. It's all speculation for now. So let's go down and learn more. We'll be right back. Let's do it together. So as we noted on the stream, what we need to do is essentially, let's go back to this node tree. All right, it's gonna take a little bit of time because it needs to simulate. But like if we click on here, for example, we view what's happening. Okay, so what we want is to hook both simulations now together, both Vellum Simulation together. And the way we do it is we need to glue those things on the rail, and also, yeah, that's basically the general thing that we need to do. And one workflow to do that, and we're learning this from scratch, so things will make sense a bit later. So what we'll do is, you see those inputs, we will make a group out of them. So group 1, and this will be a planks group, and it will be a point group, and we will hook it right there. Now we'll make another group and just keep it the same, but hook it into the middle point. Okay, so we have those two. And now we will see what we will do with these two things. We need them below the glue here because we need that glue to work. So let's put this down, take these, maybe just make them look like this. And now we'll add a merge to them, and we will merge things up. So one here, and it will go right there. And we need another merge. Let's see, right there. And we will hook this input into it, and we will make it hook right in the middle there. Okay, good stuff. Let's see what else we could do. Let's just make this a bit more organized. We see that this merge did not work, so let's make it work. Okay. Yeah, let's make this here and one there. That should work. Okay. Good stuff. So yeah, we're merging that glue wall on up and down rails. This is the glue that made this wall glue with the upper and down rail. And we still need one more glue because this won't work. If we go right there and play it, we see, okay, let's view it first. It will look a bit different. So let's go back. And boom, wait a second. All right. Yeah, nothing is working anymore. Give me a second. I think we missed something in the solver here. And that is, if you remember last day we worked on this, we had disabled our neighbor search for this Vellum solver because of some things that won't work at the moment or not supported. But let's see if this would make things work again. It's taking more time. That's good. Let's see if the stream is suffering from this. No, good. Second frame. Let's go. Yeah, it's going down again, but it's very expensive. We will see. I'm just gonna keep watching the video. Let this run. I'm gonna watch the video and see what are the next steps. So we will add another glue in between the merge and the solver. Points and boards. Okay, so basically, and I'm gonna add that here. We've added all of those things, so let's make this a bit smaller. We understand what is happening to some degree. Nope. Let's select. I'm just not used to paint, but that's fine. All right, so we've done all of those things. Let's continue here. I'm gonna add it with red. I'm gonna add the rest of the nodes with reds. We have merged before our yeah, we've seen it visually, so I don't need to explain it again. And now between the merge and the solver of the last thing, we need here a new glue operation, and that glue operation needs to be on the points level. So first of all, on the points level, and second of all, it needs to be, let's see, we need to put our groups, so the planks group, in order for it to read the information. Let's see what the third thing that we need to do here is, and that is the target geometry, and we will put it into points and make it target our let's see, so this is the target. Wait, let me rewrite this. So the target what is it called? Target geometry geo will be points, and we will basically add our lower rail to it. Let's see, lower rail. Let's see if that's true in our case, because our namings are a bit different. Let's see, he adds the bottom. Yes. Okay, that's kind of cool. That's kind of cool. Let's try that. Let's see if it works for us, honestly. So let's start recording and let's see. Yeah, okay, so we have frame 19 as we see so far. It had created a simulation. However, it's super expensive because the thing is taking a lot of resources. And our Houdini is definitely suffering from that. Could be that the points were way too... maybe I've added that attribute here or that thing here that we changed, which was not the stretch, but it was, I think, in the solver, honestly. Not in the advanced, but here in the solver, yes. This one, we think we need to put it a bit lower to 200. Let's just see how that works first. As for now, we need to make this work, so we will add the glue. And we will glue now, and I will actually do the glue operation. Not this. The vellum glue. So vellum glue. This is fun. This is really fun. I mean, I can see that I'm not understanding much, but it's fun. So that's kind of cool. All right, so let's see how we're allowed to do this. So yeah, we split the purple output here and the white output here. Let's put those there. And now we should be able to select which data types to choose from. And we should basically be able to see the glue happening in real time. So let's first hook up the right data. So our geometry will be points and our planks, correct? Good, here, it already recognized the things. Good, let's get our target group type. Which target group do we need to glue this thing on? And not on itself, but on the up and down, or group one, not stream default. Let's get it on the up and down, because it will take that down, the lower ones now. Anyway, we see that it's hooked at some point. I don't want to run into problems, so I'll save this and give it a new version. So version 2. I put version 5. It doesn't matter. We go 1, 5, 10, whatever. Let's keep going. We will start the simulation. Oh my god, this is gonna explode my PC right now. We see that the frames are actually working a bit better. However, it's super duper slow. Yeah, are they hooked? Just gonna change the view a little bit. Oh my god, are they hooked? Are they hooked or are they not hooked? Ooh. We have to let it run, so I'll let it run and come back to you. Let's go and record that part of it. So I've learned that if I put the wireframe, things will go a bit faster with the calculations. And I also learned that, damn, those are a lot of points. So let's try to fix that, honestly. So our constraint grain, let's put our number here a bit higher, maybe a 7. Yeah, just to lower things because my PC is really suffering right now. Good. Let's go into our resample here. Check our points. How many points do we have here, buddy? We have a lot of points. So let's take that down to 40. Good. Is this better? Nah, we have 40, 40, 40, 40. So let's go with 20 maybe. And this should make it work better, I guess. Let's take our next resampler and check its information. Yeah, this is looking better in performance. All right, so what I will do is I'll go to the bathroom real quick because I can't hold it anymore. So I'll pause the recording. Let's continue the recording. It was a short break we had. Oh, good stuff. Let's basically so yeah, we put the resolution a little down, I guess. Let's check if that would make things go faster. I definitely need a better PC for that, but for now, we're learning, and learning is stuff. So first learn, then upgrade. So, and play. Let's see if that would work better. Damn, that's slow. Okay, let's see. We see our planks going down. Yeah, it's working like a spider web, basically. It's gluing them, literally like a normal glue. We see. I don't like how that. By the way, yeah, because we put the resolution a bit lower and it has broke some stuff. It doesn't matter. Yeah. You see how much it's going down like this. I hope the stream quality is not being affected by this. It doesn't seem so. So cool stuff. Yeah. Okay, so we definitely need the we needed to respect the iteration a little more because right now it's way too gluey. So let's go to our Vellum glue. Ours than the solver, honestly. Yeah, here it is. Let's go with 800 here. Everything is quite stretchy otherwise, especially here. Let's make things a bit stiffer. Let's go with super duper stiff. Boom. Let's go. And here, let me see. I think the lower this is, the better. So let's check on that. Right now I'm going off script. So let's see what's going to happen. Just for my own understanding. It's taking longer, is it? Let's see. We're by the third frame. Yeah, things are quite expensive right now. What I could do though is I could make the bridge a bit smaller. And this way I will be able to maybe cut the time in half. So yeah, let's just do that actually. Let's make the bridge smaller. Let's add that window right there. Let's take our meter backwards. Let's take our, let's see, blanks gen, now even one before, add, here we go. Let's add enter and actually, yeah. Let's take it backwards, like here, fine. Yeah, that's good. Let's make it less. All right, now back into action. Let's put this backwards and yo, do we still have everything working? Seems like it. Let's view our Vellum and let's actually make the simulation again and hope, just hope that it will work. Let's see, and play. Still is quite slow. I wonder why. Yeah, I can't really explain this other than my PC is too slow, I guess. That's fine though. That's fine. Yeah, I'll let it run and we'll be right back together. We have run into 75 frames so far. I hope there was a way I could make this thing a bit faster. For now, it's just I'm gonna accept my destiny. Because I don't know, maybe I could Google it later, but for now I really don't know. But let's just look at what happened, right? Cool, we have good stuff, they're working. I quite like the fact that they are not glued perfectly or tied in perfectly, so to speak. We can see that the points that we've added on those on the geometry, its real purpose was to create to basically catch where the glue should happen. I love that some of them are not tied properly, and yeah, we're having that effect. And now what I've learned, by the way, is what those things are and how to learn about them. So before I was just saying the left one, the middle one, the right one. No, we can't do that. We really need to learn what those things are. So we can see that the left input is our vellum geometry. The middle one is our constraint geometry, and the right one is called collision geometry. So yeah, we will see. We will add a new geometry, a new node that we haven't added before. It's called Vellum transfer. Okay, that's a bit too much to the right. You can't read this, right? So Vellum transform pieces, I think. Let me check if that is the case. Yeah, Vellum X form or X form pieces. So transform, X means transform. So Vellum transform pieces. Let's check its input. Geometry to transform. So which geometry would you like to transform from those datas? So if we hook this up here and this one in here, and then we take our original pack right there, inside of... Is there a way I could take that with me? Yeah, good. And we hook it right there. Let's add an alt. Add an alt as well. Let's add a shift S. Is things actually optimized? No. Here. Now I optimize them. Let's check. Let's check. What else there to be checked? Let me check. Let me try to understand this a little better. So if I take that one, I view it, right? What would I get? Nothing. It's not working with us. Let's learn why that's the fact, and we'll... Really sorry, I've taken it right out of the glue. That is not good. Okay, so we should just like think a little bit here. Okay, so we need it out of the vellum, because whatever happening after the vellum should happen now in the geometry. And if I play that, it should, yeah, it should work right there. Here you go. But everything comes out of that will be calculated. Fine by me. I guess we need to bake it anyway. And yeah, I guess we'll take that and hook it in the output. Let's check though before we go. So yeah, we'll check that. We'll be right back with about that. That's a way of organizing things, because we can see that this node is doing a lot of stretching to be hooked back to the pack. So what we could do is add a new type of node that could help us out with this. It's called object merge. An object merge should enable us to put any output in here, and we just put it in the object one, I think. Yes. All right. And this should be now, whatever is inside of this should be the same output from our pack. And we have hooked it up. Let's see if it works. It works. Actually, one more thing that I don't like is that we don't get our ropes here, and we need them to work with this. So let's get that thing to work. Let's go back. Let's get our ropes on the planks and check where is this coming from. We have subnet. Is this the one we were working with? All right. So we will add. We'll call this sim. Row, yeah, just call it sim for now, because it will keep getting bigger. All right, now let's check where our input is coming from. It's coming right after this loop. Let's check if we could get it from a better point, honestly. Let's see what our merge here is doing. Not really a lot. Weight red. Okay, so where is our ropes? Our ropes. Why is this output here? What is going on? Yeah, we see that this is... Yeah, we don't need that, honestly. So... Okay, we were gonna try something. We were gonna try to bypass that split and check what's happening. I think it's fine, totally fine to split the UV here, but we're getting errors. Let's see what comes. Yeah, nothing comes out of here because... Okay, so let's take that split. Boom, into the merge here. All right, and let's unbypass that, and we have our rope back, I guess. Yeah, we'll get some errors here and there, and I think... Where's our null? Let's hook our null after the merge. Boom, and let's stick our null into here. And here is a perfect example why we would need something like object merge. So let's add an object merge, and let's do the same trick we've had from before. Let's add it in the object one. Good, boom, down in there, and let's see. Okay, so sim, let's go inside. Things are not working anymore. Frustrating. All right, let's go back. Let's remove our object merge. Put that thing in here. Check if it's still working. Still working. This is good. So our object merge did not really give us anything. Let's keep it to the null. Things are not working again. Or are they? Are they working? Oh, no. No. We don't need that. We don't need that. Now, why is this happening, though? Why is it happening when we add the ropes? And why is it not happening for him? Let me try to think. Is it the is it that the enumerate not doing its job on the planks themselves? Let's check. What does this copy to point do? It does copy to point on the points of the line that creates them right after all the randomization that we have ordered it to do. And then it goes right into a split. And that split is creating some of the issues because it's not going into the promotion. Maybe we need that promotion to happen though, so let's check if that is the case. So we have definitely promoted it, but I think it will still not work. Double click, check, it worked. Good. W, yes, it worked. That was our issue. It's really good to break down the issues and do this type of problem solving, so to speak. Cool stuff until now. Let's check what else is there to solve, honestly. Let's see. Let me try to think a little bit. I'm trying to think. Let's see if this works with the rest of the stuff. Check here. Okay, and now play it. And we see that it's going to calculate everything again from 0 because we've added new geometry and new points and new classes and new pieces and new everything. So what we will do is let this calculate, let it bake, and we will learn more at the same time. We will let this bake. People on the stream will stay with me. People on the recording will have a little break. We need to separate some things and merge them again. So we see here we have our planks, but what we basically need to come out of this is no points whatsoever. So we need that data to be deleted or split away from our output because we've just used it for the simulation. There's something here we have to do is called unpack, and I don't know what that means, so let's check it out. Unpack, put it right there. Let's read about unpack. Let's see, is there a way to know more information about a certain node? What does this do? Yeah, template. Where to read more? Unpack. I guess we have to go into flash, parameter channel, blah, 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 preview window, spreadsheet, show node information. Okay. Nope, not this one. But maybe in there we could see. No. Refresh automatically. No. Let's see. View dependencies. Show node help. Is that the one that could help us here? Let's see. Oh yeah, that's pretty neat, that is cool. I like that it has a browser. It's giving us the full version of it. Let's read through it, people. So the unpack backed primitives on this page. All right, cool. Since all right, this SOP takes packed primitives as input and unpacks them so they can be modified by Houdini. So it takes the backed primitives as input and unpacks them so they can be modified by Houdini. Packed primitives have an opaque representation and cannot be modified by SOPs, with the exception of simple transforms. Some packed primitives, alembic, can represent deforming geometry. However, to allow SOPs to apply deformation, the packed primitives need to be unpacked. So basically, we're allowing Houdini to work with primitives that are so like between code, so code and code. Packed primitives that are packed. And it allows it. So let's go back to the main definition. This SOP takes packed primitives as input and unpacks them. So packed primitives cannot be modified by Houdini out of security reasons, or out of not like security, out of like cybersecurity, but like out of so that the thing doesn't break, I guess. Parameters, groups, blah, 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 blah. All right, yeah, let's check it out. We need it seems. And it's interesting it happens right after the vellum. So let's unpack that. Good stuff. We need to also split some stuff around there. So splitty. Let's splitty some stuff. Good. Here we are splitting some things, and we will split our vellum object or our, let me check, what is the number one thing that I need to split in this case? Well, we need to split our planks. The grouping that we've done that is right there. We need to split that and actually check where it's been split. So null, just to see what is happening in here. What does this null do? Okay, so we probably just need to proceed with this. So it just is about the rope. So we're splitting the ropes from the data of the planks. So let's merge them before the attribute deletes, I guess. Let's check that, because I think we need the same type of attribute delete there, and we need it to hook over here and check if that still animates. Boom, it is good. Now let's keep this on animating as we go. We will learn some more. So I've learned now that we actually have done the merge the other way around after the attribute delete. So we keep the data, I guess, and then we need the orient along curve. Stupid orient along a curve right there, right after the merge. Okay, this is looking good. Let's see what else is there. Oh wait, sorry, the orient along curve happens just for the ropes, excuse me, and the merge happens there. Okay, so let's keep watching. Let's look at the bigger picture. If we need this to work before our sweep operation that happens right there, rope gen, we need the sweep operation here not to happen on the planks themselves. So we also need to split that. So splitty. Here we go. Let's check what we're splitting first. Well, go back here first. Have we split this properly though? We see that it's not really cooperating. I need to go back a little bit more just to understand what is happening. Attribute delete. Yeah, this is not working anymore. Let's put this here. That's not the proper way. Let's do it invert. So invert selection. Yeah, that's proper now. Good. So we have our ropes. Let's delete that. Then we have our merge, initial merge, after the attribute delete and after the orient along curve. And now we need, after the simulation, to split our planks. And to do that, we need to split. Let's see. Not the bottom object, not the pieces, but the planks. Well, don't we need to merge them first? We need to group them first, I think. So if I go into the vellum transform and then we unpack, let me get a split right after that just to check what type of split do we need. So let's add a null here and just take it out in there. Check what we're splitting. If we are splitting stuff here, diagonal rope, no. Lower rail, no. Planks, ropes, yes, that is one of them. Upper nuts, upper rail, vellum object, index, piece. We need the index as well. That is not working. Yeah, so those are also vellum object. Is that the one? No. Yeah, we haven't grouped them yet. Okay, so let's group them. Let's give them a group. One way to do this is to do it from the outside of the sim. So let's do it right there and right now. Let's go into our null. That goes into our merge. Let's see the merge here. Yeah, that had merged our ropes. Good. And our ropes had been grouped somewhere up there, somewhere. Yeah, they've been grouped somewhere. All right, so let's add a group here. We will call this group planks. All right, so let's get that to work. Planks, here we go. Yeah, planks here too. Good. Let's check if that works with our split. Not this one, but the one that we just created. So let's go inside of there, wait a little bit, let it work. Good. Planks rope and planks, just general planks. So we split that. Let's, all right, so the split works this way. Let's cut that, delete this, go back here, delete this, paste that we just cut. Okay, is it gonna work? It's gonna take some time for it to work. It's really suffering. Let's check. Let's keep it going. All right, we're gonna pause that. Let's record that. So split. And yeah, good. Let's split that and let's not hook it up. Oh my god. Oh no, this is gonna create a lot of problems now. No, what have I done? All right, maybe we can Control Z that and see if it works. Okay, let's pause. Do it in Houdini. You have to click escape a lot. Okay, so what I will do is create a split. A total brand new split. Put nah, please. All right, escape, Ctrl Z. Let's break that connection. All right, split again. Good. And now we'll choose what we're gonna split from this group. All right, let's save, by the way. All right, saving, complete. What's happening, man? Come on. Oh, wow. Wait, is it doing the simulation? It's doing the simulation to 278. Okay, escape, Ctrl Z. Let's take that down to 1. Come on. Let's go. Escape, Ctrl Z. Escape, Ctrl Z. Escape, Ctrl Z. Delete. Escape. Delete. Come on, man. All right, so take that back, please. Dude, come on. 0. Okay. So, split. And if I hook this up, would you calculate it again now? Okay, good. Now we need our planks and planks rope to be splitted. And please split that and take whatever coming out of that in here. Check if that is working. It is not working. Fine by me. Let's add a null. Let's check what's the problem. Null. We're splitting that. Yeah, that's good. Let's add another null. Let's just hook it up here. Check what's happening. No rope. That is the problem we need to solve. We have split our ropes, correct? Let's see our attribute delete. Where are our ropes, buddy? In the Vellum solver, do we have ropes? Where are our ropes? Damn it. Merge. Good. Here. Good, 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 good. Merge good, merge good. Vellum glue. Good, good. Solver is a problem. And why is that though? What have happened to you, my friend? What did we even do to you now? Advanced, it's okay. Visualization, okay. Okay, forces. It just doesn't want to show up. Wow, this is not fun. Okay. I mean, I am frustrated, but I mean, come on, right? Why is it not working now all of a sudden? Do we need to simulate you? Yeah, okay, now we're having some results. 3 frames, 4 frames, stop. Don't simulate anymore. Please stop. Yes, good. Go back to 0, please. 0. Ah, is it because of 0? Okay, maybe that was the mistake. Good. So this is good. This is good. This is good. Good. Working. Output working. Split. Boom. Here. Only ropes. Boom. Ropes generate. Working, working, working. We need our flat shaded. And view that with an E and R. Good. It is working. Good, people. We have found and solved so many issues so far. This is part of learning, failing. And that is what no one wants you to see. And I'm here to show you how that works. Okay, you fail. You get frustrated. You fail again. You get more frustrated. And then at one point, you keep playing around with the settings. Boom, you learn something new. Wow. Everybody's so afraid of that. Everybody don't want to show that. But hey, we're showing it here. No matter what. I will keep doing that until I can't do it anymore. Let's see. Maybe today will be the day. All right, so let's watch some more. Good. Let's see. All right, so I'll pause that. We will check now the functionality of the whole system. So moment of truth here. Does the output work? Click, and it's going to be a huge mess. Okay, click, view. What do we have in here? Things are typed kind of working. That is without the planks, so our planks need to replace the other output we see already. So let's do that. Let's change our output for the planks, which is weight painting red, weight planks blue. So that thing is hooked from that thing, correct? Yes. Okay, and that thing is hooked on the left, I guess. Let's check what this is all about. We have our planks. Now, instead of that merge, we kind of need... Let's see. Okay. Let's see. Our split here needs to be merged. And one of the merges need to be gone. So what we've done here is what we've added a null that goes out of that merge. And then it should go out of here, replacing that merge. That is a mind blender right there. Okay, so we have our planks group. We've added a merge. We've taken the output of that merge, put it into a simulation, and now we need the output of that simulation to work instead of the merge. And that is, I would say, simple, because we just need to add it in the weight painting. So that being said, here we go. Let's go weight painting, my friend. Let's put you right in there instead of the merge itself. This should solve it. Let's check on it. Boom. Click on it. Click on it here. No, that did not work. All right, what did I replace? Let's turn it back to what it was. That has came out of the merge. Oh my God, this is gonna be interesting. Damn it. Let's see. The null here is creating this. Then we have the sim. Let's add the null here to make sure we have our planks. Good. Planks are here. They are processed. They have a simulation of some kind. We need that data. We need it so bad. So let's add it somewhere. Oh, come on, please. Please stop simulating. Please, this is killing me. Please stop. Don't simulate the 9th frame. No. Please stop. ESC. Okay, that's the... Just press ESC. Alright, so let's go back. Here we are. We have tons of issues. Frame is 909. Play the first frame here. Good stuff, I guess. And now we will take that null and see where we will put it. So I'll put this thing a bit down here and check what I could do with it. Let's see. We need it basically instead of this planks group. or comes right after that. But we kind of need every connection that happens here, because otherwise we will kill the timeline, and we don't want that. We don't want to kill the timeline. So what we will do, take that merge, split it, so we have the signal split, so to speak. Let's split planks and planks ropes, and now we have split that signal. We should be able to, let me try to think here. What have we done here? We taking our, that should be our last merge, correct? That should have everything in it. So what we'll do is now, it's anyway not in it anymore, right? So if I add it here, boom, that should add it, and the split would be meaningless. It won't really. It should work now that it's taken its data to paint. Huh? What is this paint doing? What is the split doing? Splitting the ropes. Good. The splitting the ropes work both ways. It splits them this way and it paints them with a single color. And that color is rope material. It's actually just applying a material to it. And then because of the split, now we've added some type of weight painting. If I go in here, it's making everything look black, and now it's applying that type of effect. However, when I try to view that effect, we are out of sync. It's not viewing anything. Same deal here. And the last merge is breaking, or is it working? It's working. Let's see if it's working with the frames as well. So if I change this to frame 4, yeah. However, we're getting mixed merges. And we will solve that right after our bathroom break. We're back to you. We will fix the merge, hopefully. Let's check how we could do that. We have our merge 3 here. It's doing this type of problem. So we need to find where those blanks are being duplicated. My guess is here. Make blanks blue. All right, so inside of here, we find. All right, and we're gonna go through this now. What are we getting? We have output 2, output 1, but both are incorrect. Planks weight, sorry, and planks weight here. Yeah, we are getting double the stuff. How to avoid this? Where's that data coming from? Weight painting red. Let's go to the weight painting red. Let's check where the data is coming from here. Right from this merge. We basically want to be able to, how to do this. Let's take this out. Let's put it, now wait, we need it though. We need it there, correct? And so, let me try to think what is happening here. We applied the rope material with a split. Okay, let me try to think. Pulse material. Okay, so we don't need the planks here. That's definitely the case. However, we need our planks, the processed ones. Oh no. Okay, no, that's fine. That's fine. Okay. We need our planks to be. Let me try to think here. Oh damn it! Come on, Jack. Try to think. So we needed that merge because that is exactly where it came from. However, we don't need that to hook right there because that data need to be happening from here. So I solved it before. It just didn't show up or what. Let's check everything. See if the simulation is being duplicated. No, it's not. That is good news. Oh my god, we're going to 6. All right, ESC. All right, 1 is fine. Good stuff, y'all. Cool. Yeah, we got a nice bridge here. Looking cool. All right, let's see what else we could do. We have an output here. And yeah, okay, so far things are well. Let's learn some more trick. I'm gonna add this to the recording. I think it's worth checking. So we have game art. My man from Jordan. Uh, talking about subs and stuff like that. So I was wondering what they mean completely, and we've Googled that a little bit. And we see that old school guy from the Houdini, the side effects forum, saying, first thing, set your desktop to technical, etc., etc. Houdini scene is actually composed of network folders and object inside those networks. You can traverse these folders with the network pane. Okay, folders are associated with a network type. We have acronyms for the network types and the nodes inside these networks. Sounds very techy or tech heavy. Object type nodes in an object type folder. Okay, surface operators. Okay, so that is what it means, surface operators. I thought that SOP would have meant like surface off or something, you know, in between, but it's really an acronym. Is that an acronym? I don't know. So surface operators are the subs. Or geometry nodes. Okay, here you go. They are inside an object folder. They are used to construct and modify geometry. Good. Yeah, we've been playing with those for sure. Any kind of geometry from polygons to volumes. Good. Now, DOP is everything simulation, and that include pop, vellum, and the other categories of simulation. I think so. All right, so let's read into DOP. Those are the dynamic operators or simulation solver nodes that are used to construct simulations. So we've been doping so far. Simulation read in geometry. So one of the things I could do, okay, let's just keep going. Subs and passes this data to the DOP solver. Shops, however, are shop shading operators. Okay, that's cool. Are material that represent a shader to apply a geometry. Okay, that sounds very cool. Some are hard-coded with Vex, and others are folders that can dive into and modify VOPs inside. All right, so VOPs are vector operators inside VOP. Vector sounds like vector graphics, but I'm not sure if that is the same, honestly. So yeah, these network nodes are used for everything from building shaders to modify geometry. Yeah, the VOPs, that's what we create. Those are the visual operators, right? The visual way to code things, at least. Like the graph editor in Unity, the equivalent of that. So far I understood it, of course. The Vex is the actual codes of the vector expression language. The code language used to write shaders. VOPs are wrappers around Vex code snippets. Yeah, exactly. It's just like the visual representation of it. So far I understood it. Then we have the CVEX. CVEX is the context agnostic vector expression language. That's cool. So it's a language, it's, you know, on its own. Not toxic. Context agnostic vector expression language. This has replaced all the Vex specific context throughout Houdini. Interesting. It is generalized language that uses the same environment and functions in anywhere inside Houdini. I don't quite understand that, but we could go deeper into that as we go. The COPs, which are the composite operators in composite type folders, used in image compositing operations. So that is rendering, so far I understand. Shop is text. So Game Art says shop is texturing, but shop is kinda being deprecated and material is replacing it. Cool. But that is also sometimes is being referred to as shop. Yeah, I guess once you've made like a name or an acronym for something in a computer program, it's kind of hard to replace it. Cops is kind of dump, nuke, or Photoshop. So they should have called it... Oh, cops are... Are you saying cops are kind of dumb? What are you doing here, Game Art? No way you just said that. ROPs. Let's see the ROPs. Render operators inside ROP output directories, which are used to create render output dependency graphs for automating output of any type of data and for triggering external processes like rendering. So ROPs are the render operators. But let me try to understand that. I can't really understand it totally, but I guess it's like hooked to the render operations. So for example, if you wanted to render different type of data such as color ID and things like that. Yeah, Cups is kind of dumb. Yeah, I think they are working to make it better. Okay, gotcha. Chops. Channel operators used to create, the moment you press render, you automatically create a ROP. Ooh. And you're just learning, you're saying, huh? And you're teaching me everything. Chops, channel operators used to create, let me check, my wife texted me, just gonna check on it. Oh, okay, passed. Okay, good. Chops, channel operators used to create and modify any type of channel data. Let me just give her a like that I read it. I don't have to text, I don't have time to text, but like this and everything in between. So channel operators, interesting. That's what I learned so far. I will start with simulation soon. Amazing. That's cool. That's really nice. Which which tutorial are you following? Just asking because I might also check it out. Cool, layout. We got that for now. Let's close that. Cool to know those things. We have that boom effect. I really like it. Let's see what we can do with it. There's still a lot of learning to cover. So what I will do is I'll pause. Okay, so what we've learned so far, y'all, is in the Vellum constraints grain, we can actually add mass like, oh, really? Can we now? Physical attributes right there. That's awesome. We can actually do that. That's so cool. So more mass would mean heavier objects. Less mass would mean, less heavy objects. I wonder if I make the planks just a little bit... well, I kind of made my ropes quite stiff. So I'm trying to think. If I make it lighter, would they barely move? And I know I rendered 30 frames now, but I have to go back. Let me check that. All right, rendering. Let's see when they go down. In the meantime, I'll read the chat. That would be around 10 months in Houdini course. The cheapest tier is 45, but it covers all the videos. So the other tier gives you access to the mentor. Yeah, I believe you. Just there, if I would compare the current workshop I'm attending with its focus community on the objective plus the type of workshop, the type of the workshop, like it's like Grayson is a technical artist that is currently working at Naughty Dog, and he's making a course, and that was the main attraction for me because I was like, finally a technical artist is making a course. That was like my main thing, like a technical artist in the games industry. That's exactly the goal I want to reach. Yeah, but anyway, if we go back here, we see that this thing is, yeah. And also DoubleJump Academy has a lot of free courses that actually cover a lot of topics regarding Houdini, which is really cool. Okay, so anyway, let's keep playing that. Yeah, so when we added the mass, when we added less mass here, we definitely given this thing, how to say, less weight. That is why it's not going down anymore. And now I notice that our ropes here are not stiff at all. So we maybe need to make them stiff. So let's check our constraint walls, diagonal rope. Let's check how stiff those are. are quite stiff, but they're not acting stiff. Do I need to bring this backwards into, I don't know, 8, just 8? Let's go a little bit back. Let's render those just to check it out. Let's see. It's gonna play. Let's see. Let's see. They're not that there. Are they stiff? Are they stiffer now? Is that the question? Damping ratio. I wonder what that does. Damping ratio. We're hovering over it. Let's check. I really don't like how like the ropes are just like doing this type of deal. But I bet it's because the lower rail is taking a lot of the. They're stiffer than them. I guess that is what's happening, or because there's like a little to no mass. This is what we're getting from that result. I don't want it to render too much, so I just want to see what's happening. Now we barely have mass on the planks basically, and that is, yeah, I don't like it. So what I'll do is give it more mass because I want it to drop down. I want those things to go, yeah, to go lower. So let's go to our grain in our mass here. Oh, look, there's so many cool things. Dynamic friction, attraction, weight, repulsion, weight. Wow, so many awesome things, man. Okay, let's see. Let's put this back to 1, bake it all over again, and we'll interact with the chat as I pause the video. Make this my theory to why this is working right now. I think the points that are connecting this point with this point is not so far away from each other. This is why we're getting a nice result. So in order to test that, I'll go back into our add point, enter, and give it more space. And now my PC will definitely die. All right, let's kill my PC. Whoa. What happened there? Whoop. That is not good. Okay. We need to get this back to 0, to 1, sorry. And put this here. Yeah, now it's working again. Good. And let's see how far down this will go now. So going back to our sim, my friend, let's go all the way to the Vellum solver. All right. Oh my God, we see horrible connections here. That is due to the, yeah, we need to make those resamples a bit smarter with the, yeah, we need them to be more, how to say, we need them to be dynamic is the word I'm looking for. So if I go with 70 here and I go back to our Vellum solver, check our points, we have our points working, and now I'll make the ultimate simulation. All right, so let's see. As I interact with the chat, I'll put the video on. What? Thing is working faster, y'all. What? Why? It should work slower. Why does it work faster? Oh my God. But that's kind of cool though. What? Why? All right. If someone knows why this worked faster now, like with all the senses in the world, this should not have worked, correct? Just gotta read the chat a little bit. If he's the first time, if he is a first time in your stream, obviously, yeah, you told me that there isn't, but you kind of figure one that works for you. Yeah, my friend, exactly. Procedural, yes, that is exactly what I was looking for making this work with the resample. Okay. Let's make the weight, but my theory was right. The more mass, the longer the connecting points are apart from each other, the further away they are from each other, the more the mass will play a role into this. So one way to fix this is to go into our mass in the Vellum constraint grain, and if you can't see it, it's in the physical attributes, by the way. Click that and go to making that 0, make it half. Let's make it half, and it should theoretically, and now I'm gonna make a screenshot. it should theoretically do this. Let's check it out. So now it's right here. It should be now around the upper rope. It should be doing that type of deal right there. Here we go. So what we will do is rebake this, since rebaking is so easy now for some freaking reason. Let's check it out. Good, clicky clicky, go back here and bakey. All right, we have more weight. No, we have less weight, sorry. But still stretchy. Okay, we'll make it have less mass, maybe. Or we'll work on the stiffness of things. One way to work on the stiffness is to go into the Vellum solver right there. Forces, simulation. Nah, solver. Right here. This 800 should actually do the work pretty well. Smoothing iteration 10. This I think is also killing the performance, but I'm not sure. Let's go here. Let's go into our glue. Yeah, we glued things. This should work. Or does it have any stretch here? Damping 0.01. I mean, that's just a glue though. Let's not mess with that. This is our constraints up. So our upper rails seem to be working well. The walls, the down is quite... it could be stiffer. Let's go with 8.5. Let's go... Yeah, let's keep the upper ones quite stiffer. Less stiff, sorry. So let's go with the 1. And... Game Art, hey, take care, my friend. And it's nice to catch up with you too. Gotta do some work. Same here. And we'll join you later. Thank you so much for joining, my friend. And salam. Good, so let's go back into our Vellum solver again, and I'm very glad that it actually works. Let's let it bake, bake, and yeah, it's much better now. That is much better. It's taken longer time. Oh my god, look at that! I'm sorry to scream, but like, look at this. This is amazing. The pin, however, one of the pins are not working anymore, or... Oh, no, it is working. Amazing. This is lovely, guys. This is so awesome. Look at that thing, man. Cool. Okay, so we baked things. Let's go back into our output and check if things are working. What does this make? What does this do? When you middle mouse button click here, it looks like that. All right, let's play that then. Ah, it's not playing inside of here. It's funny. Okay, let's see. It's gonna bake it again, I think. Wondering why we're still getting the lines. That is confusing. But we'll check it out and see what is happening here later. Okay, good. Now back again. Can I get rid of this thing? Yeah, okay. Now back here again. And bake that. Okay, so the sweep operations are taking a lot of our... They're taking a lot of data. Or a lot of time to compute. And we still need to fix that issue, I think. Because why else is it happening this way? It should be baked already. Yeah, that's definitely an issue we have to solve. Yeah, I think the sweeping operations are happening each and every second, and this is not doing well with everything else. I think we need the sweep operation, honestly, before our... yeah, before everything else. And here we see this thing showing up. Why is it showing up? We don't need it to show up. Like, not at all. So, where is it happening, so to speak? Is it here? ER. Yeah, it's still happening. Let's check this. ER. Yeah, we can't view that. But we have to, anyway, check what's happening here. So, ER on that. And ER on that. Okay, planks are showing, are getting colored. What is output 0 do? Maybe we don't need an output on this one, honestly. Let's go back here. Check our last result. We're still getting those results here. ER, I think we still need to solve those things. Let's see. Rob Gen. ER, good. It is working. However, what is happening in the merge here? Yeah, that is what we don't need to happen. Where are you getting your information from, my friend? What is the resource? Yeah, that's not good. That's definitely not good. We don't need that to come through here. So ER on that. Good. Let's check our last result. ER on that. ER are just the shortcuts I'm using. Let's see if that's quite faster now. Still calculating. It's still calculating quite a lot, actually. All right, so one of the tricks I want to do now is pause this, and I'm just gonna go with the flow right now. I decided to not fix stuff right now because they might be fixed later. And yeah, so now we will add some stuff to communicate the simulation with Unreal, and we'll see how that works. So we will right click here, type properties, and we will add in the basics a maximum of 3 inputs, and we will apply that. And what does that do is it gives us 2 more inputs to play with. And now we will name those inputs. So if I go to, let me check, swan back. All right, so if we go to our input output right there, here we go. We should be able to name things. So if we add the first input, our first input is anyway our how to say, like this, those 2 points, I guess they're called curves in curve input. Let's just call it like this. That is the one in Unreal where we put 1 point and we place it in another point and it should work. The second input we will call the collision input, and the third one will be called cutter input, because we will add the ability to cut our bridge, which will be really cool. All right, so apply, accept. Let's see what comes next. Let's add some stuff to our system. One of the main things that we need to add definitely is our... Okay, so now we added the... Okay, too much going on. So, one by one, step by step. We've added inputs here for Unreal to be able to communicate things. Now, one of the things that we will work on later on is to add a box that will cut things through our... let me visualize it for you, because it's quite hard to understand, even for me. So here, snippet tool. Let's go inside of here. So what we will do is basically we'll be able to add a box that is super wide, that no matter how big the scale of the bridge is, I'm just gonna visualize it for you here, that it would still work. All right, so here we go. And that cut through here, just so I could visualize it for you all. Okay, so this box will cut basically all what's inside of it, and in this case I think it will be that part, so it will cut it, and then the bridge will go this way, right? It will be cut here. Actually, it will drop down like this. So yeah, we will add that functionality, but in order to add that functionality, we need first to work on our toggle that enables or disables the simulation. Sim enable, right? Because right now it's quite heavy. And if we add that to the Unreal parameters that we created, we will be able to control when it happens and if it happens, right? So that is awesome. I quite like that fact that we could do that. One more thing that we definitely need, so we will be able to cut this, and I wanted to tell you that we will only use the box here the same way we added those two add points, right? To test things. Those two add points, they exist in Unreal as curve. So the box method also exists in Unreal. So we will just add that. That's why the box, that's why the cube. Good. So far, that is understood. Now, let's start with enabling, disabling our sim. With the first thing we will start with is type properties. Then in our type properties, we will go to the parameters. In the parameters, we will have to add a toggle, which we have added already. It's called start the sim. Yeah, all right, let's keep that then. Start the sim. Good. That would have a menu channel. Yeah, it has value of 1 or 0. Then we need a switch for that. So what we'll do, we'll enable our toggle here, the menu. We'll go inside of here. Go to our sim where it happened right there, and we need a switch for it to happen or not to happen. Yeah, we need to control, we'll be able to control that now. Awesome, let's put this here, and now we'll add our switch, and that switch will be called turn on sim. Okay, good. Turn sim. Nah, not just turn it, but turn it on. Turn on sim. Okay, that will have the parameter. If I go here, we'll hook it right up in there, and we'll say absolute channel reference because we want to be able to control it from here, right? So that makes it now into two things. Either null, which is nothing, which will be connecting our... Okay, now it's going to be difficult a little bit. It will be connecting our merge from up there into our turn on sim, which will be turn off sim in this case, and our sim input into it. So when we enable or disable, it should work. Now it doesn't work, now it works. Now it doesn't work, now it works. Okay? I'll watch the video and see exactly how he does it because my node system is a bit closer to his. So let's keep watching. All right, we'll be right back. So the way to merge this is that we would need this thing to go into the sweeping quite fast. So yeah, let's hook it up here. We split our... Yeah, we split our... Let me try to think a little bit. The null is coming from the merge. Okay. The split here will do nothing, which is fine enough, honestly. Because later on we'll have the planks working or merged inside of here, hopefully. Not merged yet. Keeps going, keeps going. All right, so our merge here is going upwards and only going through that. All right, so what we could maybe do... Null, right? I will add that null here. Wait. Actually, that would work. We will add that null, honestly, right into, or right next to our merge here. So let's merge those two. Right here. And yeah, we'll just merge them and take them into the first input here. Here we go. And now this should be the other way around, basically. Yeah, but it is working. It's working the other way around, but that is... How can I say? I just take this one, put it up. Yeah, now it should work. So start sim would start it, and disable sim should disable it. Good, this is working. Let's just check if we disable it, if we're getting that output that we want by this merge. So what we're doing here is we're doing the sim, and then right after we are splitting things. So first split goes into the null, which basically takes the rope only, and that split is coming into a null here and right into our weight. And then this merge is the main merge that we need. And so if I start, good, disable, good, start, good, right? It's working. Yeah. Good stuff. Excuse me. Okay, so we will work on it now, one by one. We have our start and disable. We will disable our sim so things can go smoother with our work and we don't have to worry so much and rebake everything every time. That is one way to work with this thing. Good stuff for now. Let's check our yeah, let's watch more. I'll be right back. Go back into the recording. I'm trying to guess how things are working right now because I have reached that level that I know some knowledge, and we'll try to guess things now, how they could work and fail. And this is how I'll learn. So first we'll add a box here like we discussed before. That box will be hooked onto into the cutter. All right, so cutter is here. And that does nothing right now, right? The cutter doesn't do anything yet. So we have to work on that. All right, so this is our box. We will just for testing, basically, make it now, place it somewhere, make it big. Here we go. Okay, make it big in this way too. Make it huge here too, because our scaling of the bridge is procedural. So we have to be able to do this. All right. And its thickness we will probably put on it. And I'm not sure because it's in an Unreal. It will be able to also work. Okay, good. So far, so good. Skip that as a template. Put this thing and view it. Okay, so here is our cube or our box that will be determining the cut where it will be. Okay, so let's see how that works. All right, so decided to stop in the middle of it because I really wanted to know more on my own without any help. So let's check that out. Shift S, good stuff. Let's so we've added that box, right? So that box is hooked into the third input, and the third input should be, let's see, that's our first input. Where are our two other inputs? Where are you guys? Let's see. It should be here, right? Go back. Third one. Yeah. Okay. Where is the third input, damn it? Alright, we gotta just go with it. See if we can find something that's not hooked anywhere. Oh, damn. This is a bit harder than I thought. Why is it not working for us, though? Huh? Curve input? Something did not get established, or what? Save. Okay. Why am I not getting the numbers here for the input? Trying to fix this. Let's see. Where is it? Right there. Curve input. Can I paste that? What is this called? No. What? Ah, 2. Here it is. 3. Here it is. They were hidden. Yeah, we got them. Good stuff. 2 we don't need not right now, but the 3 we would. And we'll just add a null just to remind us of what the thing is about. Boom, right there. And this thing will be called bounding box. Good, bounding box. And we'll see how we'll work this out. First, we would need a merge. Oh, what is it? Merge. What's it called? Merge object, right? Object merge, sorry. And in the object merge now, we will add our null. Good, and now we will cut it and put it into the sim. And in the sim, right here, we will add our object merge, and we see it's not working because it's in a hierarchy beneath it. So // 2 hierarchies beneath. We'll view it. We have our cube. Things are working. Our box is here. Amazing. What we needed to do is I would like to disable my sim. Sim, please shut up. Actually, now we are inside the node, so it will start no matter what. Well, frame 1 then. We'll go back to original. Good. Now we'll create a smart grouping, and I'm really excited for that because our smart grouping will be from the pack, and if we view our points from the pack and enable wireframe, they are actually made out of the points they have to be spawned on. I don't know why I'm not getting the actual viewport that I want, but anyway, you see it like here. So what we could do, we could add a group, and we could use our cube, our box, as a bounding box. And this is something we haven't done before. So if we put this on the bounding object input on the right side, and we put our pack on the left side, which is the side for the input. It's called required source data. And now we will basically enable our keep and bounding regions. Right? All right, let me try to figure this. Let me try to keep this. I'll try to figure it out from my head. Points. We need to work with points, correct? And base group. Let's add our base group. Created, ordered, all type. Let me try to think. It should be bounding box, and then we could find our. How can we hook it up? All right, let me check that out. We'll be right back with you. Okay, that is quite cool. That's quite cool. It's a bit similar to Boolean, honestly. So what we would do is, you guessed right, keep it in bounding box, but instead of bounding box or bounding sphere, we have bounding object, which is the name, the literal name of this input, bounding object right there. So it's actually configuring, it's deleting, or it's grouping. Right now it's not deleting anything, it's grouping these, and we will call it the cut region for now, region. All right, so that will be cut, and how to cut things is by blasting them. So blast, see ya, and let's see if that works if we choose the right group. Cut region, here we go. Now we cut it, we're able to cut it pretty well, and we should be able to hook this up back again inside of this. Yeah. Or there must be a way where we can have both methods, and that I think that could be with a switch. All right, so I'll be right back with you. Let's do that. Okay. So yeah, it is basically correct. This is our frame one. I just don't want to mess it up. So yeah, you just connect it this way, and what you would do as well is that you would take the same group and now take it into the ropes. So if we take the null here, we see, we have a lot of points. We have our, our stuff here. Let's just put the points away. We have the nuts, we split them, and then we have split both the upper and down one and the sides. We resampled each one of them, so we need it to happen after the resample is done. So let's paste it here. And let's keep it called cut region, but instead of the blast, we will create a polycut, which should work better with our type of data here. So let's just add it. We'll take the merge here as an output and put it back in here. And now we see nothing is happening because we need to say cut points and then take our cut region, and it is literally taking the points out. Now save a new version of that. It's called incremental save. I forgot what it's called. Anyway, let's go to our Vellum solver and let's play that. All right, giving it a second to simulate. Let's see how that would work. Let's allow it to simulate. Yeah, that is taking a huge time now. Yeah, but we'll just let it simulate, let it do its job. And we'll see right after. Okay, I'm gonna just pause the recording. Let's go step by step, guys. Let's see. So what we need now, this is going really well though. Like, I really like this. So what we will do is take it back maybe to frame 1 and keep it like this. We need definitely our, let me see, we need, what do we need? need split, split rope, split, 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 split. Okay, so let's go to our first split with our nuts. Here we are. And we'll create object merge, which will enable us to take that attribute just for the organizational purposes. Put it somewhere else. So we'll just drag and drop now to object 1. Okay, so we have it. Now we will go take that thing a bit down, like let's put it right. Okay, so what is this thing doing? Why is it not inside? It is inside now. Okay. Now, these should be our nuts. We can see them right here. What we will do is... It's a bit of a mind-boggling thing. It's called the type of node we will create here is called point. And please, if anyone knows on the stream what it means, let me know definitely. So point deform. It should be able to deform things due to the time. So here we have the mesh to deform. This is our mesh to deform. Rest point lattice. So that will be the first frame, and our deform point lattice. So the point we want the lattice to reach. And we should think about this as similar way like in Blender when you create a lattice. Creates like a grid. And what it's doing right now, it's taking the first point of the animation and the last point of the animation. It's creating a lattice around it per frame. And now it will deform our nuts going forward. Okay. I get that part so far. So first frame is basically needed from our Vellum solver. So let's hook a thing where we could add a certain frame in a node. So it's called time shift. Time shift should allow us to do that. Let's read through both of their documentations that just so our understanding is better of them. So let's go to point deform overview. Just make this a little bigger. Overview. This node computes how a point cloud, the deformation lattice, deforms compared to its original rest point position. That's exactly what we tried now to explain. And applies those deformations on the input geometry. The node works by having each point on the lattice capture and influence nearby points on the model. The closer the points, the more influence computed using the Elend metabol formula. Yeah, this is too much to do into math right here. No idea what is that. This allows you to animate proxy geometry and transfer that to a higher resolution mesh. In that case, so yeah, it's a lattice that takes its data from different nodes. And it's called point deform. I don't want to read through the whole thing because it's quite big, so let's skip that. Time shift, let's just go through the very first page of the time shift, and this way we could be able to read through it. All right, made it a little bigger. The time shift SOP will cook at its input at a different time than it itself is cooking on. This allows one to gain access to earlier or later frames. Okay, so I get it. That's kind of cool. I really like this node. That means if we don't need to book until the frame 1560 million, we'll add a time shift and go to that point. We'll fast forward, basically. Note that the time shift SOP doesn't cache the input. So depending on how the data is accessed, the cache node may be more efficient. Let's see what that means. That's my current understanding of this. It could be completely wrong, so please leave in the comment if you think this thing could mean something else. Okay, so time shift. We have a time shift, and it's on frame 1. That is great. So let's take our frame 1 and hook it up. Actually, this is hooked to something, so let's alt-click. Alt-click here. Alt-Control-click. Alt-Shift-click. Alt-Control-Shift-click. Alt-middle-click. How to remove a connection, I completely forgot. A control, I think. It's Control-click. Yeah, here we go. So let's keep it on frame 1. We'll hook that up to our Vellum. And we will hook it. Let me just check where this can be hooked.
And then at once...
actually, in our merge, not in our Vellum solver, surprisingly. So this whole thing will happen right after the merge here. So it has nothing to do with the Vellum solver, but it has something to do with the merge. So let's take our merge, put it right here, then take our time shift, put it in the middle. This thing will be our geometry that we want to shift, which are the nuts, as you can see here. And now we need the endpoint to when this should be to when and where this should be deformed, and I will look this up together. All right, so that was short break. Basically, we have taken a time shift, and it was on the first second. We made sure that this is our start input or our reset point lattice. That is our very beginning, and now we need the point deform to deform along the time, and the time is fixed in the merge. So this will allow us now, if we play it over time, to see it deforming. However, what we don't need are those deformations, so we need to fix that somehow or another. Yeah, look, we don't need that. We don't need this thing unless we have like motion blur, and they will barely be visible. But I think this will create a lot of bad geometry. So let's fix. Understood one more thing that we've done before. If you remember when we have unpacked, right at the end, I think we unpacked something. We unpacked here, and if I go through it, it is our planks, and we've unpacked them because we have packed them here. And the pack does make the geometry basically go back to 1 point and 1 point only. And now we will use it again, but we really need to remember to unpack it back again. So basically, to solve this issue of this deformation, we will pack those things into one single point, the median point, and make them go along it. And then once that's done, we will basically unpack them again. So object merge, let's go with packing. Pack me, here we go. Let's go. And the pack point, if I view it, should be one single point, honestly, but we will, yeah, here it is. It's one single point, and we need that point to be applied on all of them. We'll see how that is done, and I will be right back to change the value from centroid to pretty much, wait, this is our pack. We need from full geometry, so it's taking the centroid middle point of all of them. Now we're understanding the pack a bit better, and we can instead make it do that work first of all as let me check name path name no path, well, let me check again. Point cloud, bounding box, centroid hidden, centroid origin. Nah, that's not working. Okay, I'll be right that out. One way we learned before how to split things and make them work better is through connectivity. We've had that issue before where we had line going like sideways because we have added splits, and node that solved our issue was called connectivity. So let's add connectivity of some sort, put it right there, and this should be able now to split us each and every node here. And once we hook it in the pack, it still doesn't work, but we need to, I think, change a couple of things here. For example, instead of points, we'll add a primitive. Let's see if that had worked. Maybe a string instead of primitive. Let's go back to our connectivity. We're just gonna, okay, so keep it to point. Let's add a string instead. And we have pieces now. Okay, and that is basically, let me check. Full geometry point, centroid hidden. Centroid? Okay. Full geometry. What am I missing here? What am I missing? Do I have to add wait a second here. Name and add piece. Does that work now? Piece. Okay, name attribute. Let's try class. Is that working now? Full geometry, central origin? No. Display as point cloud, bounding box, centroid, hidden, full geometry. Something is not working properly, and that is due to the error that says invalid name attribute for partitioning, packed fragment, primitives currently only support primitive string attribute. Okay, so here we've had to add primitive, I think, and now it's piece, and now we could actually communicate. Can we or can we not? Yeah, is it in the middle? Yes, it is. It is. Okay. So basically, what I've noticed is that when this was on points, it didn't work. It had to be a primitive to in order to be an attribute type string. And so we made that, and then we basically add the name attribute. We kept it to full geometry to set to the centroid of it, and we work with the class now. Okay. Good. This is how it was able to read it. Now let's see if it's actually working. Yes, our nuts are being hooked and they are being deformed as points but not as geometry, which is exactly what we want. Now in the end we need to unpack this, I believe. I'll be right back. I'll let you know what are the next steps. Let's do that. Cool. So as I have thought, and we are getting better and better and better every time, so let's add an unpack. Boom, hook that up. Wait, let's hook it up right there, and then we will add a merge and merge everything together because they've been split pretty well from before. So we'll just merge those values, put that thing here, boom, it's working, and then boom, in the unpack we're getting an error. Let's see how that error is acting with everything else. We have a class. What is it saying? A mismatch of attributes on the input was detected. Some attribute values may not be initialized to expect values. Example, name, index, top object, UV. Maybe we could delete those attributes if they're causing any issues later on. For now, we see our nuts are deforming. However, they are not quite following our lines properly. Like here, that is wrong. The rest is good. It's just because of the delete node, I think, we're getting that error. Let's go a little bit back and check it again. Yeah, we're getting a lot of issues here. That is... okay, wait. Let me rebake that, actually. So let's do it right here and give me a rebake of this. How do I rebake things? Let's see. Why are we getting those deformation now all of a sudden? Let's see if it works for him. Well, I think I get what the problem was. We were lucky enough that they had the same problem. So basically, if I go into this, we see that all of our points here are there. And we need to fix this problem. We needed this before to make it work, but it's coming from pack 1. We don't need that anymore because we've added some information after pack 1 and we need it to come after the blast. So let's boom, drag and drop here, and now we should be able basically to view the simulation correctly. Okay, so play that, boom, it's broken, very sad, and it's gone. Amazing. This is looking good, y'all. Cool. So much progress today. I am loving it. So let's keep going with the progress. Good stuff. We got this thing working. It is going pretty well. So what we will do is now add some more inputs on the geo level. So we'll go right here. We have added our box for cut. So let's just call it cutting box. Here we go, and that is something we will be able to... So what we were doing so far is testing it, and we'll be able to change that in Unreal. We'll do it in real time, baby. Let's go. Cool. So here, and then what we will add now, as we see here, we've added that on input on our on. It's called collision input. That collision input now will be a mix between two boxes. So box 1, and let's make that box. That's something we will be able to do in Unreal as well. So, but let me show you how to put the inputs first, to test it and to hook it up properly, and then we can add the proper connection to Unreal later. So we'll just add like one box here, make it a little big, and it doesn't matter the size now. This is just for testing, y'all. So yeah, we'll put it like right there, and we'll add another box. So that will be copy paste, and our next box will be not Xbox, but the next box will be like, let's say right here. Give it like a slight rotation to see if that would affect things later on. Cool, it's right there. Things are working pretty well for us, and let's take it right there. Maybe check how that would affect different things. Now we will merge both of them. So mergey, let's go boom here, boom here, boom here. Here we go. Now we have two boxes that are affected in the collision way. This is not set up yet. We will set it up now. So let's go in our inputs. Let's go to our second input. Our third input had already been taken. So let's add a null. And our second input now will become that null. And now we'll just call it collision. All right, amazing. Let's add an object merge, baby. Here we go. Let's add our null inside of the object merge, and we have that object merge here. Now cut it with Control X, and now we go back into our sim and double click on the sim, baby. Here we go. So what we need to do is put that bounding box in the Vellum solver. Makes a lot of sense. Let's add it right there. Right, good. Now we see that mistake because we are a hierarchy beneath everything. So we'll go ... and we'll put it into collision geometry. Collision geometry right there. You can see it, the third input on the right. So we did that. It's gonna take a while. It has to recalculate everything because we are at the 42. What you could do is press ESC and put this to 1 again. Wait, is my numpad not working? All right, it is not working. Good. Now we have it on 1. We will play that simulation again and see if it is faster or slower. So play, baby, play. So we'll put done. The thing is this simulation, as nice as it is, and it will be done very soon now in front of us. We'll see it. Here it is. It's quite cool. It is working with the geometry itself that we generated procedurally. We can see that there's a bit of an issue with the stiffness of the upper rope. Could be fixed easily, I suppose. Yeah, it's just quite stiff. It's like noodle stiff, if I may. Okay, so yeah, we need to fix that, of course. We could fix it easily. But so far, what I learned is... this is awesome, though. It looks really cool. It's looking really amazing. What I learned is this thing will be very heavy in size if you were to add this exact simulation in Unreal. It won't happen real time, of course. That is why we're doing it inside of Houdini. But if you have an environment, where you have to model by yourself a bridge and have those strings work as such by hand, it will be a bit difficult. But because you have this simulation now, what we could do is extract those 3 frames and make them loop back and forward as such, right? This will make the size not super big, like at the end, like for example here, just like have 1 frame adjustment maybe between those 2. And here, basically, you created that bridge that is broken. This is one of the benefits of making things work this way. Also, the proceduralism of it all. That means you can have 2 bridges, 3 bridges, whatever, etc., etc. Now, we could go forward and basically rig things. So put the rigs inside of this and export it as an FBX. And this could work much better. It will work much better. But in this workshop, we're not going to go through it. Could be something we could look into later. Yeah, this is quite stiff. I'll leave it for now because it will take a lot of time to bake again. However, it's looking quite cool. I really like the results. So what we can do is basically go back to our geo level and merge everything with the boxes. Just a few things. So merged here and merge that here. And now we view the geometry of it all. Let's delete the points. Let's just view the geometry basically without the W, of course. Here we go. Now we should be able to see things. Within the simulation, it is not working, however, because we have disabled it from our hierarchy here. Let me delete those things too. Okay, so we have to enable it. And now it will take time. And here we see our work. The nuts are definitely not going through the delete, which is something we need to still do, of course. We need to delete those nuts that need to be deleted. We could do that. We could fix it right now. Yeah, the rope is very thick. It's very... All right, so let's put it to shade, actually. Flat shaded. Why are we still getting the... let me see. Yeah, here we go. Yeah, this is how it looks like. Even as just an FBX, if you export this, this is looking amazing. Yeah. This is good. It's hard to model this by hand. It won't look realistic, but if you were to export this on your own, it looks already amazing. Here you go. Just have that, export as an FBX, and you're basically already have done something pretty cool in your portfolio, or in the game for that sake. Like just this frame here, imagine if you have an environment where you have to create like a time that stopped, or time, you know, like something happened and time stopped, but your character is still living in that space, and you basically are playing in that level, right? And the things are switching every 10 seconds, so basically the level is changing every 10 seconds. As long as you're doing like solving puzzles, it starts like this, the bridge is straight, and as you keep solving puzzles, it gets destroyed, and you're playing that through frames, right? So we're not exporting this in a huge a huge file. It's called Olympic file, which will end up in giga and gigabytes of file, but you're exporting just the FBX still frame of this and importing it in a game mechanic. And yeah, so yeah, it has its own benefits to make the simulation in Houdini. The proper way to do it is to rig it yourself. We maybe will be able to do that in the future. For now, this is quite satisfying, looking great so far. We still need to delete those nuts, so let's go right there and delete them. So sim, let's go inside of here. Let's take the output where they're actually being deleted, and that is inside of this group here, this group right there. It's out of this group, so what we will take is the input and add an alt, and go down, add another alt, and merge. No, wait, this won't work. Trying to think here. How do we? Okay, so here's how we do it. Delete. Okay, and now take that group, copy the group, go back here, paste that group, delete that group, and put that thing here, and take our box, the bounding box, which is right there. Maybe copy the same object, merge, put it right here, and now we have our bounding box that could be used for the grouping, and we could split things. Right now we don't have the nuts anymore. Let's check if that actually had worked, because we linked our object merge right there. So if I go into our deform, or into our into our merge right there, we should be able to see with the frame that we don't have those nuts anymore. Great. And if I go now on a bigger level to our geometry in the merge here, we should be able to see that the nuts are not existing anymore. Just click on the merge just to see it a bit properly better. Here we go. That is our bridge. Let's go in a point like 71, and it should bake it for us. And if I go, like, for example, if I make this a bit bigger into a 150, right? 150 right there. Okay. We will have 150 frames, and if I go to the 150 frame, we should have a future point of this, unless it has to bake everything, and it seems like it has to bake everything, so we'll add an ESC and go back to our point 26, and I think we baked an 80 frame here easily. That we went again upper than we needed, so 58, here we go. Yeah. Imagine that, just export that, and now you have an environment piece where you have a bridge that is already broken. Amazing. We only had to bake 80 frames of that. Things are quite cool, guys. I will go on a bathroom break. We'll be right back with you. Thank you all for joining. Okay, so I'll pause the recording. We finally reached the 40 followers. Amazing. Thank you for the follow, my friend. And yeah, more to come. It's only been 3.5 weeks so far, but we're pushing this. We're getting forward. Thank you for the follow, my friend. And yeah, hope you enjoyed this. All right, let's keep going.
Without further ado, why don't we just dive right?
So let's go here. One thing is not working in our simulation is this spaghetti kind of noodle thing. We need to be less stiff. It's way too stiff right now. So let's go into our simulation node, which is the red node right there. Here we go. If you just came here, my friend, we have all the episodes available from the beginning when we started day 0, day 1, all on the YouTube channel. Check that out if you basically are lost in all of those nodes. We started from 0, from the beginning, so everything is covered, so don't you worry. All right, so let's see this here. The thing here is way too stiff, so we have to edit its stiffness. So let's go right there. Let's check its stiffness, my friends. Okay, so object merge, is that the one? Object merge, is that the one? Vellum solver, is that the one? No, we need the actual thing, which is the upper rail in that case. If we put it back here, we see it right here. It's the upper rail, and the upper rail is having the problem, the issue is right there. We see that it's either the rest angle that it's making the stiffness or the actual stiffness of 4.2. This has the same stiffness as the walls. The walls are not stiff in the same way. Let's see here. This is a 5.6. It's still not doing the same thing because due to the heaviness of the planks. So it's fine to keep that heavy, but it's completely not okay to keep the upper one heavy. So let's take that one down to 1 again. Let's check what we can do. So I'm putting that down now back to, I don't know, 1. Let's see, it's gonna load a little bit. We'll basically hit on escape and put this back to 1. And yeah, we will rebake our animation anyway. Let's put this back to 80 frames, which would be enough. I just want to see how it would play out if it was on stiffness 1. We will play this as we watch the video. All right, so here we are watching working. Why is the upper? Hey, what's up? Good, good, good. How's it going, my friend? How's it going? Is it your first time here? Nah, it's not your first time. I can see you that you commented before. Good, how's it going? So let's see. We're going to figure this thing out with the upper rail. It's not going well at all. Like, look how it's slamming into the ground. Okay, so there's something we've changed here in the upper rail that probably needs better value here. So 0.8 probably was not the good idea. Maybe we need to go should we go up with this? And how much up? Also, what is the bend doing? Does this go like 0.05? What happens if we put this up? And it's just the worst thing to test things, by the way, when you mess with 2 values, because then you have no idea which value worked. But yeah, we just gotta do it like this. Try to put both of them into the extreme and rebake that thing. So let's drink some stuff. So what else do we need? We need now to watch, note down the video stuff that we had. Trying to think. It already slammed, right? So it's good that it happens in the beginning here. It slammed already, so we see that no matter what we do, it's still doing it, and it's maybe due to that number here. If I take that to 2, is it still gonna happen? All right, so first of all, stop, go back and simulate. All right, yeah, at least we have it now. Quite soft and not as stiff as before. It's not as spaghetti as before. You know, pre-cooked noodles. We don't want that effect, but this is looking okay-ish. However, it's still doing this weird bam, bam, bam. We don't need that. We want something that is, yeah. Let's try to stretch back to 1, I guess. Let's try to keep this into 1, and let's try to play that again. Let's see what happens. Boom. Let's go. Okay, it's still doing it. Let's see why that is the case though. It's literally crashing. So we might be able to need to define that value again to 400. Let's try that. Let's play it. I've defined the constraint iterations. Yeah, it's still slamming. Trying to understand why it's slamming, and slowly we'll get there eventually. Maybe the bend needs to be, I don't know, quite higher, I guess. And let's click here and rebake this. Wait a little bit. Yeah, it's still happening. I wonder why. I think it's due to the other... Ah, it could be that these are too stiff, right? These here. All right, so let's check them out. Could be that they are so stiff that they're bringing them together, like pulling them, right? So let's check why that's happening. Let's go to our constraint walls and let's go and check our... Yeah, here you go. This thing is pulling, so 9.5. Let's try 9.5 and see if it's still pulling. And bring that back to 1. I don't want it to be too stiff. Okay, good. Let's play that. Let's see. Let's check it out. I hope it's not gonna happen. I mean, to some degree it is. It is happening. Now it's like an explosion or some sort of... Yeah. Something that we don't want to happen. Boing, boing, like this. Oof. Oof. That's tough. Let me try to think about this. Yeah, we'll stay here until we fix this. No problem, buddy. 1.5. How does that look like? Second frame, boom, play. Second frame, still there, still going. Let's see what we could do about that, though. Whoa, but now it's way more, right? It's way more. So we probably need that into a 0.5. Let's check what that does. Let's see. I feel like the bend on the upper rail is too big. So upper rail has too much of a bend. So let's put this back to 1. And let's go back to our Vellum solver and rebake this. All right, now we have less bend, or what are we having? We're having like quite the chaos. So... Damn it, what's happening? Is it too much of a value, this one? Can we just put it back to 1 then? Bend 1. Let's just bring back normal values. 1. Let's put it everywhere. Just 1, 1, everything. 1. Let's see how liquid this will get now. Let's see. 1 and 1. It's probably not the right answer, but we will see. All right, play that again. Simulate. Let's see. Okay. Okay. Okay, no more craziness. I see, I see. It's probably what we needed to begin with. So let's see. Oh my god, it's working kinda. Let's see if it will stretch right afterwards, if it will just go and keep stretching like cheese, so to speak. Let's see, yeah, it's pulling too much. That's already bad. That's already horrible. But we know now at least it's in that value. Okay, good. So now we will take it to the other extreme. And we'll go step by step by this. Step by step. Okay, so what we will do is go to our Vellum. First of all, give me an 800 iteration. Like we had before. Now we will revert to our normal values one by one. Okay, so we took that from here down to here. Maybe something in the middle might work for us in every one of them. So let's check. Yes, good. Let's check here. Oh, I didn't notice that I was able to take the glue as well. All right, so glue is super stiff. We need the glue to be stiff. But do we need the rope to be stiff? That's the question, right? So let's try one by one. What happens now? I put the rope, the glue between the ropes, super duper strong. Is that the word? Yeah, it should not stretch. So let's see. Let's see. It's pretty slow. It's going like quite slow, I would say. I'll keep playing it until we get it right, guys. We will keep streaming today until we get this thing right. There's nothing away that's gonna take us from this. So, well, what it could happen now is that the glue will still stick together, so this thing won't stretch down anymore, but everything else is still stretchy as hell. So we will check how we could fix that. Let's check first if it's glued together everywhere. Let's stop that. And now we study it. So we stop the simulation. Here we go. we kind of are stable on the sticking part basically, but everything else is stretching because the values are quite low. So let's go. Let's do this thing. All right, so bend, give me something in the middle of this value and something. Oop. We need to put this back onto 1. Yeah, not that it simulates again. Okay, so we'll put everything on 10. What is it? 10. 1e plus, or is this plus? Plus 7. Let's keep everything on that value. Let's check what's gonna happen. This here too. The reason we have so many options is because we can decide what the material is made of. And rope are stretchy, not quite stretchy though. So we will check. Now it should be half as stretchy. Right now it's pretty much melted cheese, you know? So we don't want that. Now we're getting the same stuff that were happening. So we know at least that's already too much of stiffness happening. But we'll keep watching. It might be due to the bendness. Might be the bend. I still need to check what the bend does. Might be we made it too bouncy, right? Bend, bounce. Is that the same value? Is that the same thing? I don't know, but we will know right now. So we'll keep it going. We see that they are, how to say it? They're jumping they're jumping between each other quite a lot, like this. Yeah, that's not good, man. Does that mean that they are quite stiff, or does that mean they're quite bouncy? And I wonder what is the proper way to know what they are right now. Okay, so one way to figure it out is to go on each one of them, take the bend value back to its normal value. I think with double click, alt click, which one takes it to the normal value? Whoa, which one takes it to the normal value? Revert, paste value, paste, delete channel, include intake, lock parameter, and lock parameter, revert to default, control middle mouse button, control middle mouse button, control middle mouse button, control middle mouse button, control middle mouse button. Here we go. The bend, the original bend is on 0.1. I didn't notice that we changed that at all, so we will just click. Cool. Bend, just please go back to your normal value because I didn't notice that I have changed it to begin with. So, and now we will simulate again. Let's see if that's a bend issue or a stiffness issue. So bake, let's go, baby. Here we go. We have less bend. That's good. That's kind of good. Might be the movement. I'm not sure. Let's see. There's definitely still a movement going on, and that could be due to the fact that they're quite stretchy. Let's let it bake until 40. I will basically learn a little more about the next system and how we are going to do it. It's quite difficult to follow, but if we have struggled right now, we will struggle so much in the next week, which is week 3. So I better keep my S together, right? And basically try to understand what is happening with the video and try to follow up as much as I can and keep you all entertained and on the same track. So just for now, I'll start watching the video again. I will keep it on X2 just to get the aspect of what we're doing, and I will note down some stuff.
I wanted to do a quick update video for the Breaking Bridge simulation.
So we have the Vellum solver, blah, blah, blah.
So I just wanted to quickly create a video showing how you approach that. So without further ado, why don't we just dive right into doing that. It should be pretty straightforward. The way we're going to go about this is really just using our groups and creating some extra constraints. And we can also control the strength of those constraints after we create them. Let's go ahead and get into it. So right now we have our color geometry, and we are grouping on both sides here what we want to delete. But instead of this deleting operation, we can actually just disable our blast for now. And on this side, instead of deleting it,
so instead of deleting everything, we will split everything.
we want to split it off. But I'll show you what happens if we split. It gives us a result that we don't really want. So if we were to split off this group 4 that we created, it would look correct on one side, but on the other side, it still thinks that this is all one primitive, so it'll take this weird looking shape. So instead what we'll do is we'll use 2 polycuts. And we will just cut the input.
Alright, the system starts with 2 polycuts. So we have our group that blasts. Alright, so that group that blasts, we needed to split into 2 polycuts. Alright, so polycuts. Nice stuff. What's next?
On the other side. So we'll do delete one side here. And then on the other side, we can just cut not root 4. There's an exclamation point in front of it. Do the inverse of it. So now we have two sides.
So one that cuts everything but all but, and one that cuts but all. All right, so let's see how that works. Damn, look at our bridge. Now we'll see it working in real time soon.
We'll call this break section.
Break section, call the group. All right, so we will name the group a bit differently. We'll call it break section. Just following it up because there are a lot of steps. So that is exactly what we will do now. We'll go step by step. I'm noting down as much as I can now, and then we'll go step by step right after that.
Copy this name, over here, and should all be working still. Yeah. Okay.
Oh, I didn't notice I was still recording, so yeah, we have definitely, after the bake had finished, solved the problem of the uncooked noodle type of effect, and now they're all cooked. All look like they're cooked. However, when they start, it's going like bam, and we don't want that at all. And I wish I knew how to fix that, honestly. Could be due to the scale. We know that the more it is in that direction, the softer it is. Trying to think. So what I could do though is now check the value without the blast, without blasting anything. So basically we'll just avoid blasting, and we'll just let it overpass everything here too. We did cut that pulley here. We need to cut the other pulley as well. So let me get where that is, right there. Good. So let's keep that. Let's override it and make a new simulation out of this. Yeah, that's exactly what we don't need though. So let's get back to the stiffness. Try to fix a couple of things. So we start with that. We will start with the first stiffness setting here. Constrain walls. Let's make those super stiff and check what's gonna happen in the first frame of the Vellum solver. So now we made the walls super stiff, but yeah, at least they're not. Yeah, look, we solved that part here. Okay, so that's good. Now we know what is the issue. Almost. Let's put it into +9 maybe. Let's take our up. I mean, that was too stiff though, so let's put it into, I don't know. Yep, +8 maybe. Let's check this one here. Wait, that was the bend. That was the bend though. We just changed the bend. Okay, so let me check on the bend. Wait, we just made it. The bend is the one. Yeah, makes sense. Because like an uncooked noodle would not bend. But if you, yeah, that makes a lot of sense, man. Okay, so let's check our values here. Let's make it into like 100,000 of a value. Also in the bend here, 100,000, as well as here. Let's return that value to what it was. No, Ctrl Z. What is this green value here? We don't want that. Let's see how to return that value to what it was. I don't know. Anyway, for now we'll keep it like it is. But why? Restore, bitte, please. Come on. Why is it not working? Revert to default. Please. Revert to default. Oh my god, what is that? Bruh. What are you doing? Okay. It's something is green here. I don't know why. Yeah, we put it to 100,000. Let's see how the bake of that will look like. Actually, wait a second. Yeah, that is too stiff right now. I mean, wait. So what we've done is we limited the bend. Now we check and we see that maybe they were all way too stiff. So let's put the stiffness down. Back to, sorry, the stretch of it. Let's put it down to 1 just to see what is going to happen. 1, and here also stretch 1, and here also stretch. Oh wait, that could be the problem here. All right, so 1, and let's put the stiffness to 1. And nah, but that will make it gluey. Anyway, let's check, since it's not cut anymore. We'll check how it's gonna work. We'll check how it's gonna behave. All right, so keep going. We still have the same problem, or do we have to rebake everything? Okay, let's rebake everything. Let's see how it's gonna react. Yes, yeah. Ooh, okay. That is what happens when you don't know what you're doing. Okay, so stretch value was too less. That is what we get so far. Okay, so that is the stiffness value. If we put it to less, this will happen. Let's keep it on a million. No, wait, that's the bend. Let's keep the bend. Million. Put this on a million. We need to learn those things, guys, and that's the long way. Is the way we're choosing to learn this. So it is what it is. When you don't have enough resources, that's how you do it. Okay, so let's go again. Yeah, that's way too stiff, dude. But I have no idea why it's acting like that, though. Why it's snapping as such. But it is acting in the right way. However, it's quite... what is the solution here? Is it definite? Like, do you think we've messed something up here? But that's the glue. The glue needs to work, right? What happens if that went to 1, though? Just checking. All right, play that from the beginning now. And go click on this and play. Whoa, yeah, you could see that the glue... It's still happening, so it's not there. It's not there. So that's not part of it. Okay. Keep it on 10, then. Let's check our different values here. We have the issue of... Let me check. That's the down one. Let's keep our bend to 1. That will allow it to be a bit like cooked noodles, right? So 1,000 maybe. Check here. 1,000 maybe as well. Here as well, 1,000. And if it does work, we'll at one point we'll just review the video from last chapter and go through each and every option and focus on the bend as well with it. Yeah, that looks a bit like a rope. However, the stiffness of it is now completely broken. So what we'll do is check our values with the stiffness now, one by one, of our stretch. It's stretching way too much. It's becoming like a glue. Another glue, but like a it's how to say, you know, when you have a gum and you stretch the gum, and that is what's happening. We need a much stiffer material. Let's try with a 5 here in the constraint down. As for the upwards one, we need also, let's try a 9 and let's try 1. Let's keep it stretchy a little bit. As for the walls, these can also be stiff as well. I can see that we have messed with this value. Let's keep it back to 1. It's doing that effect that we don't need. So basically, you, my friend, need to go back to 1. And you are on 2. We don't want that. You are on 8.5. Let's keep everything on 1 and check what happens and what works and what doesn't work. Let's bake. All right, so one frame by frame. Let's go. Please stand where you need to stand. Don't go overstretch. It's overstretching because the stretch... Yeah, but it is working, however. That is good. We need that type of simulation to happen. So basically, that's a good news. The simulation will be over soon, and we will play it. That's pretty much a bridge, but it's too stretchy still. It's better than before, though. Much better. Why? Before we were following a tutorial... And now we're following our own understanding. We're testing ourselves. We are putting ourselves in danger just to test, to fail, to put it on stream, to put everything on the line. It doesn't matter, man. It does not matter. Okay, so I noticed that this thing is way too stiff, the lower one, because you see here, this effect is happening. Now if I break the bridge, and you will see it will create the noodle again. And that could be solved by the bend, I think. Let's see though, let's see. So what we will do is enable all the stuff we turned off, and we let overpass. You keep going, buddy. All right, first put me back on frame 1. Good enough. Put me back here. All right. Cut me, please. Cut me through. Nice. Cut me here as well. Good. Yeah, we cut everything. Cut, 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 cut. Here we go. And simulate. Let's see. Let's see. Let's see. Let's see. Let's see. Let's see. It's not doing the anymore, because it's not doing the scale thing. When we added the scale from 2 to 1, it's we took all those parts out. Okay, thing is going down pretty nicely, I would say. Let's keep watching it, and let's keep an eye on it as I note more stuff down. Okay, so we'll go here. What we need now, and I noticed that I haven't been recording, that's fine though, we can show it to you guys. So if we go back and we play that over here, you can see how stiff this thing is. You know what I mean with thing is this, those lines, those are not made of steel, those are ropes. Let's not forget that. So you can see they're still kind of holding up the structure here, and that's almost steel level of like stiffness, right? So we need to check that stiffness now. We're gonna need to put it into check. So here we have stiffness of 1. Everything is working well. What we could do, we have 2 choices. We could either play with this, go here, put it on 8, correct? Give it a value, yeah, that's already 10 times less stiff. So what we will do is put this back on frame 1. Here we go, baby. Let's go to our Vellum solver. Let's play that. Gonna play it. We're gonna let it play, actually, and keep watching here. What is the solution that they're trying to solve? So the fuse, we could make it be applied on only one group, which would break pins. Break pins. Cool stuff. Let's do that. Is this still baking? Yes. Good. Target group, closest geometry, closest target point. We need to put it on closest target point. Let's see if we can remember all of this, honestly. Closest target point. Let's see what else we need to do.
Will be the other side of this. So I think we should just use... we're going to have to make another group for the other side.
Same thing, okay.
We can group all of this together, and this will be a separate group. And we can name this like...
Alright, so this needs a group by... or just group, basically. Okay.
Main sim.
Main sim. Okay, main simulation, I guess, yeah. Okay, let's see how stiff those things are. Are they still holding the structure? We can already basically determine if they are or not. This is quite holding the structure right now still. Like, this is not good. Because the rope, the upper rope, needs to fall. Like, fall free. But let's see what happens after that, actually. Let's keep it baking. Let's see the result of that. So bake freely, my friend. It's, how can I explain this feeling? It feels so... I'm gonna put this on stream and leave it from the recording. Okay, I'm trying to understand this thing one by one. Okay, so we have a value of... Nope. Shift... What is it? Control Windows T. Yeah. Now it's on screen. Let's check here. So stretch. What does the stretch mean? You have a gum, right? And you stretch your gum. You will make it stretchy. That's all. The higher the level of the stretch, the less stretchy it will get. So it will just stay here. Okay, that's a gum. What's a less stretchy thing than a gum? I don't know. A pen, a rope. Let's just go with rope. Okay. And of course, gum, cheese, whatever. Those are quite stretchy. Like they go quite stretchy. They stretch. Okay. Now, the next thing is the bend. The bend can be resembled with the noodles. A noodle pre-cooked can break. And that is what's happening with our columns here. They are calling columns. We have a rope, right? And they are doing this. They are stiff in the bendness. They don't want to change. And what we've been doing is changing the gum feeling of it. We're making them more gummy. Yeah, but if they can't bend, they can't work. And the bending is like a cooked noodle, right? You have it bending all over the place. All what we need to know now, which higher value does what and which lower value does what. We need them to bend. That's all. Walls, you need to bend, guys. So which stiffness level do we need? Okay, let's just read it. Parameter, bend stiffness. Okay. The stiffness of bend constraints to deal initial value change by factor of 10. So if I take that thing down to 100, how stiff would it be? How bendy would it feel? We will see that in the first frame if it's too bendy. And we will see that immediately. Like the screenshot said, right? Let's see. Let's see if that's the case. Let's see if that's true. Okay, I'm gonna zoom out a little bit. Here we go. And this thing is falling. It is bending a little bit. When it hits, does it like go all the way to bend? And this is the stretch. I should keep in mind the stretch value. We need it to be a rope. A rope is not stretchy at all. So that is fine this way. A rope will just break. It doesn't work like a column. It holds things together. That's all what it does. It doesn't stretch. It holds things together. It bends as hell. If you take a rope and you drop it, it bends. It's not made of steel. That is the feeling we're getting here. The thing looks like it's made of steel. Although that's not the case. And now we're already getting a better bend value, you see here. All right, so we're gonna just stop a little bit here. And let's go to the... Yeah, that's what we need. That's what we need. That's the result we need. Here we go. Here we go. Go learning. Go learning. Hell yeah. Let's go. Go learning. Good. I'll pause it for the record. Now, so far, we have got our stretch. Yeah, this is pretty good, guys. This is exactly what we needed. It's not like soft as noodles, or cooked noodles, or stiff as uncooked noodles, or like steel or anything. So basically all what we had to do is change the bend, and the bend was right in the walls constraint. Here we go. And we had to change this one right here in the bend, 1 to 1, just pretty normal stuff. We pretty much, I think, need to do this to the other ropes as well. Not to the level of 1, but to the level of pretty much, I mean, especially the upper one. The upper one seriously needs to bend. So let's go with, I don't know, 10,000. Check how that looks like. And yeah, we'll let it bake a little bit. How many hours have been streaming? 6. Yeah, we have 2 more hours, pretty much, until we reach the limit for today, and then we have to come back to it either on Monday or I'll come back tomorrow. But I'm not sure if I will come back tomorrow. It is not 100% thing, because I'll be working on some multi-stream stuff, some visuals for the stream that I would like to have. Let's see how would that look like later. Yeah, for now, we will let this bake and check what's gonna happen. The upper one is now less stiff in the bend bendness of it. So it will bend. That is the goal. We don't want it to look like steel. However, the lower one can have less bend, in my opinion. Let's see, though, how will all look like. And we can see that the lower one doesn't have enough bendness because here it's going upwards and then down in a very stiff way, let's say. It's cool because a lot of the feeling of art comes, especially when animation is something you do manually with your hand, you know, each frame. But here, at least we have the computer to deal with it, and we have the names for everything. So it's quite fun to do, actually. It's really fun. Just I wish I had the PC for it. You know what I mean? Yeah. Well, maybe I have to work on some donations in the future if people feel like they could support or whatever. That would be nice. Okay. Let's see, is this stiffer? Is it less stiff? In the bendness of it, not in the stretchiness of it. As for stretchiness, it could stretch less because it's a rope. It can't stretch, it's not a gum. That's why we need the stretch to be less and the bendness to be more. And more means less here in that value. So let's see up to 60 frames how this is going down and see if it is actually fitting. Yeah, we'll just see how this will look like and we will judge on it based on everything. So let's say, come on, 58, 59, stop. Okay, let's stop it. Good, looking good. This is quite, how to say, it's not bending as much as I would like it to. I would like it to bend the same way the rope bends. So on one, we will go again. Check if this will cause problems, of course. So we will go up and zoom out now. It is actually faster a little bit. Yeah, a little bit faster, I would say. Drink my drink. We'll watch it. And yeah, that is the end result. I showed it to you of the other thing that we need to do still today. In the screenshot that I shared before, yeah, I'm just waiting for this thing to show me the amount of bend that is happening on the upper rail. And once I'm satisfied, I'll keep the values as is, save and save a new version. And then we will start with the idea of having the rope being cut on either side and see how that works. And it seems that it has to do a lot with the fuse, parts basically. So yeah, play. Come on, 28, 29, let's go. We are halfway there. Yeah, my PC is just dying right now, honestly. So yeah, let's check. Let's go back here and go through everything again in the watching. All right, so the problem had definitely been solved. We can see it already. It just needed to bend the same way the rope was bending. So either by the value of the ones or the value of the tens, both are fine. But now it looks more like the bridgehead broke, and for the eye, it's better looking. Yeah, I like this pretty much. It's looking amazing. Just imagine if we have vines around this bridge now. I mean, look at that. Look at how this falls. Oh my god, dude. This is amazing. I love this scene. This is amazing. Look at this thing. Oh, this is looking really, really, really nice. So let's actually bake it. Let's bake all of it. And I'll keep watching and we'll be right back with you. Okay, results pretty well, as we've seen before. We've set it on a different file. That file will stay with us in case we want to change some things. For now, I will add this different system of braking, and we'll add it in a switch probably. We need a parameter for that, but for now, you know what? Here's our blast. Let's add a note. Sorry, Alt O. All right, sorry again, Shift O. Yeah. Break system or cut system. Well, we call it cut system all, right? So it's cutting both sides and it's called cut system all. Let's stick this a bit here. All right, and now I wonder what this thing means here. Let's delete it. And let's take, yeah, our cut system all and create a new system. Oh my god, what is happening here? ESC1. Good. And now we will add a new system, call it basically, yeah, let's bypass that stuff here. Let's keep them. We need a type of switch though to keep going from here. So let's add a switch now. Because I would like to have this system to work both ways, and the earlier we do this, the better. And so instead of bypassing it, I'll add a null that says null planks deleted. For now, just to bypass it, we'll put the switch on 1 and we'll bypass it this way. For now, of course, for later we will do something else. We'll make it work a bit differently. These are our nuts that have been cut. Let's not hope they're cut. So Shift O, we will say nuts cut. Cut. Let's keep it like this for now. We just want to be able to differentiate, so to speak, our nodes and what they're doing. And so let's go here. I mean, that's a cut operator. It's just make them into a normal comment, which is a dark orange in our system. And now if I go to the other cut, which is right there, we will create a switch now. All right, so a switch that will switch the values. We'll put it right there. Okay. And this here will be our cut all, so to speak. So this and this, Shift O, cut all, dark orange. Oh, sorry, here, dark orange, cut all. And the other method will be the different thing that we want to achieve. Let's put it here, actually. Yeah. Okay, so switch should do it the other way around, actually. So whatever comes out of here is the one that gets determined. Okay, so we need the same group, basically. Just put it here. We'll call it differently. We will call it something else. We'll call it break section. So break section. What we'll also do is make our cutting less in size, which is this cutting box right there. Enter. We'll be able now to see the diameter of this. We need it to go quite close to each other, where it only takes care of one plank, basically. Not two of them, but one of them. All right, so yeah, we made it that small. It looks like it's losing one only. Good enough. Let's keep it like that. Let's save our progress so far. Go into our DGA HDA. Let's go into our sim. And in the sim now, we will start doing some stuff. And let me show you what we will do. All right, so first, if I split this, we'll realize that one of the results will look good, the other won't. And so if I split the proper what is it, diagonal rope, lower rope, upper rope, break section, this one, we will notice that one output will look good properly, like this. But the other, if we were to add another null on the other side, will become completely broken. Like if I put this here, you see how it will act like a primitive and it would just connect it again. We don't want this behavior. That's why we can't split it. Okay, so what can we do? I'll show you. We can cut. We can polycut twice and make it choose the other side. So polycut. So one all but, right? And one is but all. So let's see. Polycut, and this polycut will do, where is it? Group section, what's it called? Diagonal lower upper, polycut, diagonal, or let's see this one. Break section is the name. Here, let's see, why is it not identifying it? What is the reason? Is it because it's a point? What is this group made of? Points, okay. Polysection. Let's make you polycut, sorry. Let's make you go into cutting our... Damn it, where is it? Why is it not showing? Why is it showing here? So the cut points. Okay, so let's cut the points and it will be our break section. Here you go. And then we will copy paste it and then we'll break anything but this. So exclamation mark right there. Then we'll create a group out of this, group by range. So group by range out of this thing, and we will see now step by step how that works. Group by range, here we go. Let's hook it up to group by range right there. And we will basically, yeah, this is way too less of a box though. The bounding box is a bit too small here. But since we need one side to connect and the other's not to connect, so it's fine to be not looking well so far. We'll look into it a bit later as well. So our group by range will be called break pins. So let's do it. Will be called break. Oh wait, that's not the name of the group. That's the name of the group. Break pins. So it should break one of the pins. Now this will have the setting of let me see. Well, first we need to view it. And then we need to press enter. We need to put it into points so we see which points are being selected, right? All right. So we will invert the selection and put the start to 1. And now we see if we add the numbers here, which points are being selected and which are not. This point is being selected. This point is being selected. These are not. But what we want is it to select the connectivity as well, affect disconnected geometry separately. As we see, selected, 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 selected. And let me check with the video real quick if this is all the settings we need to do. Okay, so what we will do, we did everything correctly so far, but we will also need the right side of it. So copy that and paste it again, put it beneath it. Is it beneath it? No. So let's put it here. And we will basically select the other way around. So boom, boom, here we go. Now we selected the right side of it. Good. We need a bit of a bigger box, I think, for this to work. So let's go back, one more back, and go to our cutting box. And the cutting box needs a bit of a bigger range, so let's give it a bit of a bigger range. Here we go. Let's give it a bigger range. Where do we do that? Come on. Let's go. Is it saving? Yeah, it is getting bigger. Let's make it even bigger. Yeah, here you go. That's fine for now. Should do the work. All right, yeah, save, go back in the DigiDHA and in the sim. Here we see more details. It's a bit too big though, so we're gonna make it a bit smaller because I wasn't aware of how big this was getting now. Let's make it smaller, nice, go back here. Excuse me, we will make this a bit smaller here. All right, so now just for better visualization, we have the right side here and the left side here all selected. Good. What is the next step? Let's see. So the next one, the right side, will be called the stuck pins. So one will break and one will stay. That thus far we understand that part. And then next we will basically add a merge. Here we go, merge. And what we will also do is group this bully cut and group it right now. Here we go. And this will call the group here, we'll call it just like the normal sim, the main sim, so to speak, because it is just doing the actual simulation through those, the rest of them. And we will merge it and merge this now. View both, and we see both. Good. And now we'll fuse. All right, so let's fuse them, and we will see with the fuse now. We have a couple of settings to do, and eventually we want to be able to fuse parts of them. So basically we'll be able to select, break the pins, or basically make them stick together. All right, so let's see how that's done. I'll follow the tutorial very shortly. One thing I realized so far is that our group hasn't been changed to a point group. So now we have it into a points group. Great, this looks good. And if I view it, we see all the points that have been selected and been grouped. So that is good. We have merged things, looking good as well. And now with the fuse, we will see what we could do and what can we change and what can we manipulate. All right, so first, let's start with the group, and we will take our, let's see, our break pins, this one, and we will take a target group now. And our target group will be our main sim. And now we will see how we can fuse those things together. And yeah, instead of near points, because this one does this type of thing. Oh, sure, sorry. We needed to be using, instead of using target point number, we needed to be using closest target point right there. And we'll make this a bit bigger and see how this connects them. Yeah, this connects them a bit nicer than the other value, because it's basically completing the shape as well. As if least target point number does this type of deal. Yeah, completely breaking everything up. So we have no choice but to take closest target point. All right, good. Now we have the right side broken, right? And the left side completed. We will see what we will do in a second. Let's go over that concept pretty quick. So we have added a break pins, and we also need now the one that don't break. And I will show you the main difference between both, because from the operation, it's pretty much the same. So we will add a new fuse. Actually, you know what? We'll just copy the same one and paste it, correct? So we'll just put this thing here. And instead of break pins, we'll now take our stuck pins. So those are actually stuck together. We'll take our margin, put it to 10 so it doesn't have any failure. And so we'll see the difference now. And so fuse snap points. So basically what this was doing is snapping the points together. So if I put it like to 0 now and view it, it was taking these 2 points and fusing them into each other. And what we didn't want is our break pins to fuse, because we want to break them, correct? So they will stay like they are, the same shape, and imagine a sword splitting them. And what happens is you have the same sword, but it's the same rope, but it's split in the middle. So that is what we're doing. We're split it through the box, but we basically now are fusing the points together and adding the cut, right? So we don't want the fuse. Why? Because we want those points to break. Nothing will change. They're just not connected. That is all. Okay. Now if you take this point here, now we need to basically fuse them, because they are stuck pins, right? So we need to fuse those, and let's fuse them. Fuse, check, good. Here, fuse, uncheck, because we need to break them. Good things, good stuff. All right, so let's check if so far we are been working correctly. So I will pause, and good. One way to view our result now is to connect this here and make that. Oh my god. Hey, thanks for the subscription or the follow. Thank you so much. Appreciate it, my friend. Please show up in the chat. Let me know you're here and drop by, say hi. Thank you so much for the follow. We have reached our goal today for the month, and that was so cool. Thank you for the follow. I'll be right back with you. I'm just a bit busy with making this thing work. So with here, hi, you deserve a follow. Thank you so much, Otad. Where are you from, my friend? I'll just put this into one here, and we'll make it switch this way. Make it switch this way. So 0 will go to the right side and 1 will go to that connection. And that is exactly what we need. And we will connect our fuse now. Yeah, the fuse is connected. It's going, hey, hala, Fiek, from Morocco. Nice to meet you, my friend. Yeah, it's really nice to have people from Morocco here. Utad, my friend. I'm from Syria. I'm actually from Syria. How's it going, my friend? How's the weather in Morocco? How hot is it right now? Nice to have you here, Otat. Cool. Good. So let's see. We hook those things together, and we'll give it a test. We basically hooked them together, but they are not connected because we did not fuse them completely, right? Let's see. Let's see if the simulation will work. So here we go. Let's make this thing play. Here we go. Boom. They should be disconnected, and they are disconnected as we see here. It's a bit hot here, but I guess Syria is way hot. Yeah, I'm not living in Syria, that's for sure. I live in Austria. But yeah, just wanted to know like how many degrees, because here in Austria we have, how hot is it here right now? Let's check. Will be fun. Weather, and it's around, in Vienna it's 32, but where I am it's, let me check, 29. Good. I wonder how hot it is on your end. Cool, man. I really appreciate you being part of here. If I may ask you, how did you know about the stream? I'm just like interested where the people are coming from. All right, so let's see how that thing plays. Cutting it, it's cut. It is fused in the other end. That is exactly what we want. He's getting a bit of a different like result on his end, but for now, that's good enough. We'll go with it. I just searched Houdini, I guess. Yeah, okay, cool. That's really awesome that my stream is showing up, because sometimes I'm like, does it show up? Oh, that is amazing. How long have you been learning Houdini, or looking it up, searching it? It's quite difficult of a program to learn, honestly. I started 3 weeks ago. Started from zero, basically from scratch. But so far we've been doing cool progress. And what else do I want? Now I will continue watching that real quick. Yeah, a VFX and Houdini. It's quite difficult actually to have Houdini, to find Houdini for games tutorials other than modeling. Especially in terms of visual effects for games, because the workflows are, I feel like, at least, they're not as easy to understand as like, particle systems and things like that. But I'm super duper interested in that, and I can't wait to explore that as well with Houdini. It's quite fun to work with, a bit frustrating, but it's quite fun to work with otherwise. Let's see where this is going. All right, so what we will do is add our stitch of the points. What I will also do is take this and make it a bit more organized. So we'll select all those things here. Here we go, all of those. Take them and put them down. Like way down here. Yeah, maybe here even. And this is not working. Wait. First take those. Put those down. Okay, and now we will take these. And basically put them also down. Way down. There. Maybe. Alright, and now we'll try different things. So first we need a stitch, right? For the stitch I need a switch, because I don't want those systems to interact with each other, and I want it to be completely separated. So one here, and another switch, of course, right here. And now what we will do is go into adding our stitch. Stitch with a TH, and Vellum stitch points. Cool. Here we go. Now we will hook. Let me check which values we will be hooking. Please close this. I don't want this. Okay, I guess you're not gonna close it until it shows, right? Yeah, please close this. Oh my god, Houdini. Houdini, listen. Houdini, please. Oh my god. Houdini doesn't want to listen. Oh my god. What? Okay, ask one. And if Houdini doesn't listen, just press escape. Now let's check where is that window. It doesn't want to show up anymore. It's upset. Good. Let's check our stuff here. And we'll make this thing go through a switch. But switches work a bit different. Now, how to make this thing work for us? We need the thing to switch when how to make this work. If I want the switch to switch into that system of cutting like a sword, I will need the stitching here to work. However, okay, so this thing will be belonging here, but I need some type of switch to switch it off, so to speak. And that switch should be coming right after it. Okay, so switch, delete, put this thing in the middle. Once it's in the middle, now we can think about a switch. Let's put this thing a bit here. Yeah, like right there. Okay, so now we have our stitch here, and now we need our switch. Okay, so switch. Here we go. It needs to go from null, or actually from the same points. Yeah, here we go. There, that's amazing. And this yeah. No, wait. Well, we need one of them basically, and this is how it's gonna work. We need the middle points only. Good, this is working. We need another switch because we have 2 points basically. One here, delete that one, delete that one. So one here on the left, one here on the left, and one on the bottom left. Okay, so that is how it's going to work here. So this one will be deleted. Okay, and we'll just work with it like that. Let's see what else can we do to make this more visible. So Alt, as you can see here. Okay, and delete that Alt and check the rest. So both of them go in the middle. We don't want that. We want this one to go to the left. One. And this one, if this is going to the left, this needs to go to the left as well. Okay. So that is our switch. Which one is which? Yeah, this. Okay, and now we can create our stitch value. Yeah, I need the switches to work in order to continue, because I want to be able to enable and disable that system on the go. So we are so far been creating this bridge, this procedural bridge here, and we made like a nice simulation out of it, where it breaks and it connects and things are really nice. For now, there's nothing fancy to show, because we broke the system to add more like properties or things. Mainly just we wanted it to, if I go here, we wanted to cut in this way, like as if a sword cut through all those points. you know, they won't be gone away. They just cut through it and then it goes this way, right? Before, what we have developed was a system that goes and breaks through the cube, a cube, let's say. This is the bridge, by the way. Let me just hide those points. This is the bridge so far. It's completely procedural. And, you know, you have this cube here and it cuts, right? And before, I took the rope completely out and I wanted to now cut it like a sword, so to speak. And we're just following the DoubleJump Academy's workshop, Houdini for Games. So to learn more things about how HDA works. How long have you been learning Houdini for, if I may ask? And let's go inside the system we were in until Fix actually answers. Okay, so let's see. So far, this is our Vellum, and it is definitely doing a lot of stuff that we don't want it to do. Let's go back to our stitch, and now we'll make our stitch work the way it should work, and that is with the right groups and everything else. Actually, this is the glue. We don't want it to go through the glue. I mean, here, right here. That is our Vellum stitch, and we need to make that stitch work. So yeah, let's get it to work. Stitch points, primitives. Okay, so what I will do, I will constantly view the settings in the tutorial, and we'll be updating it as well. So points. So first of all, we need the stitch to work not with primitives, but with points, which is to be expected because our whole groups were points groups so far. So let's see. We'll add the points, and we will add the group of the main simulation here. So this needs also to be a point. So our target geometry and our geometry will be, so let's go through it one by one. Our break geometry, our break pins will be our geometry. So here it is, break pins. That is the one we just created. Target group will be our, let's see, our rails, our main simulation. Exactly. And now we will stitch it together, and our main goal is the breaking here. This breaking thing, or this breaking mechanism, may, if we have like a threshold of how much stress it is allowed to handle before it breaks, it's giving us the ability to cut the rope under loads of a lot of stress, which is something that is needed in some simulations, I would assume, such as, I don't know, the bridge might, if you put a rock on it, a medium-sized rock might just go down. Maybe a smaller rock will make it go down further, but then a heavy rock will make it break. And that is what we're doing right now. We're adding all those abilities to our bridge, and we will check how that is done step by step now with the workshop constraint. We need the constraint to be to closest point. It is working properly. That is amazing. Let's check what else is there. Actually, is my voice breaking up like before, or is it still working? I'm just checking. No, all right, so it's still there. We will check. We'll disable, enable. All right, so things. Okay, so what we will do now is check on the constraint itself in the Vellum solver. We see that things are probably not working correctly because we don't want that type of stitching. Yeah, it's probably not working properly. So, wow, I just said probably and properly together. And that is amazing. Let's see what type of settings did I miss here. So we will take it right back from the stitch creation, and we will check each and every option. Break pins, and we have points, yes, and we took our break pins and we put our target pins to the main sim. Closest point, correct. Okay, that is all. Something's not working properly here, so let's bypass the switch here. Let's put our switches on the left for now. We don't need them now. Let's see how it would just work without them. So it will just go forward into our simulation stuff, and we'll break all those connections and see what is the glue doing, what is the vellum doing, why is it creating all those points that are glued together. Did I make a mistake? It is right before the vellum glue. Oh, I see. Wait a second. Wait a second. It's right before the glue railings. Okay, yeah, I actually put it and set it up quite correctly, but let me check where I have failed here. Where have we failed to make this work? Is it in the actual glue that we have the not the sole proper setting here? Please stop the simulation. Escape Houdini. Please don't do anything. 1, enter. And let's check one by one. Now I lost all control over my node system. Come on, buddy. Let's go. Come on. Drag and drop network. Yeah, why is it not working? Escape. Escape. Good. Yeah, just had to do a couple of escape clicking here and there. Vellum stitch. Why is that not working? Vellum stitch. Why? What are you doing, Vellum? What are you doing? Why is it? Ah, now it's working. All right. So, okay. Now it's working, yes. That's cool. Okay, good. Let's keep watching. We'll be right back. Learned so far that the Vellum stitch had created this type of deal here. This type of stitching we could see here. The rest though, okay, so the breaking here that we wanted to work with, if the threshold is too low, it will break, and if it's too big, it won't break. So let's try it with this, with our vellum, what is it called? Our vellum solver, and let's play that simulation. We'll see that it will break immediately. However, if I put that backwards and I make our stitch value much higher, like 1,000, so to speak. And so if we go back there and I play and I make it now simulate, it should not break right away. We see that it is stuck together. That's good. It didn't break. That's good so far. This thing is way too how to say, yeah, it's way too bendy. It's not making any structure here. I like it though, but I mean, come on, this is not working here on this side. Maybe because it broke a little bit right here, but still I should make the upper rope more stiff and not bent so much, maybe. Okay, but for now we see how it's working. Yeah, it's not cutting because our breaking point is too high. Okay, so that far we understand. Let's see how we can manipulate that value and animate it in the way we want to. So far we understood. Inside the solver, there should be a way to make to keyframe the value break and add force to it. As you can see, force and source. Okay, so we will watch more. All right, I really like those points here. They visualize it a bit cool in a cooler way. So let's check how we can animate that, how we can do that. I just double clicked on the solver and we've ended up in another hierarchy basically. Okay, so pause. Guys. Okay. Inside of our Vellum, start our solver. Here we have this notebook that says, or note, wire POP forces into force to apply per point forces. Wire Vellum constraint properties and Vellum rest blend to update constraints dynamically. That's the keyword right there. And what do we need to wire? Vellum constraints properties right there. It says it in the node itself. Good. So in order to change things dynamically, we need to add our constraints, Vellum constraints property. So tap Vellum constraints properties right there. Click. I didn't even know the thing existed, but if you read it, it says this is how you add it into the dynamic part of it. That is what the workshop had told us so far. Okay, now I'll go back to the workshop, watch some more. Time to keyframe, time to animate dynamically. Okay, so let's put this into the forest. Let's first apply our grouping, which we could do in clicking this click box here and get our breakpoints. First, we need points. Where to get the points from? Let's hook it to the input one. And now we should be able to see, let's see, upper rail, upper nuts, lower rail, diagonal rope. How to put this? Let me check. Wait, not the subnetwork one, I think, subnetwork 2. Which one does work better though? Just gonna go back. One more. Into the sim and see our grouping points, and here we have break pins. Good merge, and then it comes back here. If I add the split, however, do we still have, I mean, we don't need the split every time we want to see what's inside. Let's go back here. Our 9-point attributes. Let's just go with the groups. Group our pins, rails, stuck points, up and down. Break pins. Here we go. Break pins is in the 9 points group. Break pins is still here. Break pins is group. Break pins, good. It's still here, and break pins is still here. That is good so far. We have all of those stuff. Double click in here and then go inside of our Vellum constraints property. This property should see the, I mean, let's just put it in input one, right? Do we even need to put it in input? Let me just go a little bit backwards. We don't even need that. It should basically know the break pins group, but it can't see it though. Maybe we just need to add it like written break pins. Would it give us an error? So far so good. Let's go back to our sim. Let's escape and put it back to 1. Escape 1, escape 1. Good. Okay, let's check our name of the group. It's called break pins. Good. Let's keep it. Let's go inside of the Vellum solver here. Break pins. Okay, seems to work. Let's add our, where is it? Break threshold right there. And now we could animate that. So in the beginning, if I press Alt click, this is a keyframe. We'll put this until 1000. By frame 18, it will stay on 1000. So Alt click 19, it will go back to 0.1, and this should break it. And then it should continue broken just like that. Wait, let's view it. Wait, did I not? Okay, so let's actually keyframe it. Alt click, boom, done. Here we have the actual keyframe. Good, let's view it and check it out. Okay, so we can't animate that here. Sim and click and backwards, and let's see if it breaks after that point. Okay, play. Coming down by 19. It's breaking. Come on, break. Okay, we must be missing something then. It's not breaking. Okay, let's, yeah, maybe the group is not working honestly by then, because we have errors here and it's telling us, what is it telling us, guys? Or did we have those errors before? Honestly, yeah, everything is not working right after that. So let's see the errors. What are the errors? Here, cookie was interrupt, invalid sources, sim, vellum, DOP, import geometry. attribute cast. I wonder what is causing this. Let me try to think here a little bit. What is not transport? I mean, did he basically copy the name breakpoints or breakpins, or did he actually put it from the grouping? Group, yeah, they are in the group, but how the hell is that possible though? Because I don't get those points. In the glue they go, and just let me check his system, the way he has his everything set up. The vellum break pins, output group, stretch. Interesting, I haven't done that. I think so. What? I haven't done that. All right, so let's do that. Huh. It's quite interesting. Let's play that again. Okay, let's look at it. Let's look at it a bit closely. I haven't posted the video. Sorry about that. Anyway, I'm not gonna delete everything. Okay, so Vellum Solver. All right, so let's go inside of here. Okay, so all right, here we go. Let's go there. And right here, let's take a null. And let's look at our constraint geometry or our vellum geometry. Let's look at our vellum geometry one by one. Do we have break pins? They are here, but in the stretch here, we need to add an output group. That output group will be called break pins. Yeah. Pins, let's add double S there. See what's the difference. Break pins are here. Break section are here. Group one, not main sim or pins. For primitive group diagonal row, blah, 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 blah. Okay, so it's not here. Let's check here. And we have break pins, double S. Let's check if that will show up. And if that is the problem, then we know what is happening. All right, let's delete that thing. And now for real, take our diagonal row, lower rail, upper nuts. Okay, broken. What's broken? Vellum object. But let me try to think. Okay. So up rail broken. Ah, damn. I really don't know. We might actually need to set up the thing a bit again from zero. So just delete the thing and add a vellum constraint property and check if it's updated. Let's see now. Group and check it out. Break pins. Here we go. Yeah, we had to redo it in order to see it. And now we will add our break type. No, break. Yeah, we have break type stretch stress and threshold. And let's add our keyframes. So one will be 1, and this will be 1,000, 1,000, and alt click. And by frame 29, it will be clear 1,000, and boom, it breaks 0, 1. And basically, let's do it at 30 is easier, 0.1, and let's alt click that. And now we sim. Let's sim that. And Becky, let's go. Let's see how if that works. By 29, it should break. Yeah, it broke. Damn, it was too much stress. Cool. It's really cool. I like it. Finally worked for us. Let's see. Boom. Break. Boah, it's too much stress. It's probably better before or a bit after. Like at 48, I feel like it could make it could give it more oomph. How to manipulate this? How can I take? Yeah, that's much better. Okay, it's a bit like Maya, honestly. Sim. All right, let's go, baby, and simulate that thing again for me, please. All right. Are you working? No, Esk. I think I clicked the wrong button where it basically baked everything. All right, so let's see. By 48, boom, it's breaking, and we have it falling apart. All right, so again, doop, and doof. Yeah, I like it. Good, this is looking pretty cool. Let's add our merge to it, basically. Check if that is working. Nothing is working here due to some changes we created in the switch here. So let's switch it back to 0. Right? So backwards, all the way to 1. And let's go downwards here to our Vellum solver and play. Now it should animate everything. And we see it working, and it should break. It's breaking immediately because of the stress. And now at the end. Okay, that's quite fun though. I like it. It's basically breaking too hard right now because we stitched those points, but they're not quite. Yeah, they can't handle the threshold at the end, even though it's 1,000, you know. But because those are so heavy, the planks we made them heavy, they're barely holding up. Yeah, like they can't, right? All right, but that's not good. That's not how that's not how a bridge breaks. Try to think a little bit. What happens if we said that the break threshold here is 10,000 though? Like here, it's a 10,000 alt. Sorry, 10,000 alt click, and it goes all the way to I don't know, like 5,000, and see how that breaks apart. Then it's a 1. All right, so let's bake that. Let's see if it changes a little bit. Let's see. It's nice to play with once it works. Nice to play with. All right, now play. Let's see. Didn't really need to rebake, or what's the deal here? Interesting. Oh, wait. That's not the proper. It's not the proper one. Okay, wait. Let's go into the sim. Sorry, this one. Go back, rebake. Wait, come on. Vellum solver. Let's go back and rebake. What is happening here? Is it the same values? And why is it not changing? Anyway, I don't know. We'll see. We'll see, I guess. We'll keep learning though. Let's see if it's working properly on the upper level. So like on the merge level somewhere. It's just gonna take some time. Let's just save things. All right, so let's see on the merge level if it's working out with everything. Sweep is working. It's actually cutting off. That's pretty neat. Let's go back to our sim level. Why are we getting those points and where are they coming from? Yeah, okay, so this thing is not being deleted basically, right? It's being merged with everything else. Yeah, we don't want that, so let's check that out and see what's happening. Okay, so we have made a grain, we have grouped things, planks, good. This group had been merged together. Let's just check. Then it had been added to the glue, then into the solver. So let me check solver, then it's been taken to the Vellum transfer pieces. Then here we don't see, no, we still see them, okay. Then we unpack them. We still see them. Is there a way to get rid of them though? With splitting them maybe. Vellum constraint. This thing needs to be split at one point. So let's view the nulls of each output, honestly. All right, so this thing is, all right, this thing is here. Yeah, those are the ones. And the constraint. All right, so let's split that. We'll make a little split. We'll make a group out of this. All right. This group will be called, let's check it out. Let's make this group, yeah, primitive group. Let's call it grain. Planks grain, I guess, is the one we're looking for. Good. Let's keep it into primitives for now. And then we will delete that a bit later. So what we will do, we created those groups with the planks. Yeah. And this one, planks points, I guess. So let's do that, points. And so we have created groups. So planks, prim. Prim. Let's delete this here because we already done that. So and then it goes right into the merge. What I would like to do is a split here. Let's split our prim away. And one way to check if that worked, if I put the flanks here and this one here, delete that one here, check, good. Next step, merge. It's like this. Let's check our vellum. Let's check all the way here, merge. All right, this is looking, yeah, nah, we still didn't get rid of that. It's not good. Why are we not getting rid of it though? Let's see. Group. The left group had went here. Yeah. Why did we merge it though? Let's get rid of the split and let's see why we merged this thing. Yeah, we needed it for the simulation. Definitely. Okay, good. Let's keep it then. Then we've taken everything from the solver and we've split some stuff. What did we split? The planks. But the planks kept their values from here as well. Unpack. Yeah, we need to take their values away. Split. Let's take it out. Yeah, okay. Take it here. And now we need to split our planks. Where is it? Plank, 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 plank. Why is it not transformed in here? Grain planks, right? Planks, break section, main sim, or pins, planks, rails, stuck pin, up and down, group 1. Yeah, take planks, I guess. And let's see if we still have things in here. Then unpack again. Last. Why is it not working though? It should work. Stupid that it's not working. Why is it still here, dude? Unpack. How about a split here? What happens though if I split it here? Null. Let's add a null to the left side and check planks here. And what is happening? We've split that. Let's take if it's on the other side. What? That's so weird. So weird. What is this thing called again? Planks prim. Where did those go now? One went here, got merged inside of here. Is that the proper merge though? One on the left side. In the left side it went inside of here. Then it should have kept its primitives, right? Its groups. Where is it? Prim, planks, prim. Planks means planks prim. Still have it here. Vellum planks prim. Sim or pins, planks, rails, system default. Why is it not here all of a sudden? Is it not connected properly? It's just it disappeared, or how? Why did it not transform? Here we have planks prim, and here we have planks. It's called planks here. Why though? What is this input doing? And is it before? All right, so this came in here. It had definitely changed some things. What is this called? Collision geometry. Okay, so this is our box, the two boxes that had caused the geometry. Okay, but where did our planks prim disappear here? And why did they disappear to begin with? If this is connected directly, why did it disappear? What for? I don't understand. Planks prim, piece plast, piece scale, PP previous. Breaks pins, breaks section, the group on knots, made sims, our pins, planks prim. It's right there. Let me check how we can take this out. Because right here it's just planks, but then cut region, that's all. Damn it, unpack. How can I take this out? Is it by the final result though still there? Wait, what is the split doing? Let's delete it. Yeah, okay. Let's go back to our geo. Escape all the way to 1, please. Okay, let's view our last result. Why is this here still? Damn it. Oh my god, I don't want it to be there at all. This is annoying. Okay. Well, let's follow it, I guess. Damn it. So annoying. It's just disappearing here. Like, why? The type of grouping is just, it's not existing anymore. Planks. Huh. Okay, it's no. All right. So what I want to do now, bring the names back. So Control Z until this changes. Let's Control Z all the way until these change, and then we will have the same names, and then it should basically go back to its older version. Check on the stream. I moved my mic again. Control Z, Control Z, Control Z, Control Z. Let's go back to the stream. Control Z, Control Z, Control Z. Mic is working, good. Control Z, Control Z, Control Z, Control Z. More, and more, and more, and more, and more, and even more Control Z, and even more Control Z. What are we doing now? Where are we? How much Control Z did we do now? Seems to be a lot, but it still hadn't changed their names. I'm not sure if it does go back that much. So let's just call this planks. Call this planks again. And check if things are working. We definitely broke some stuff there. Merge. They're still here. Isn't that amazing? Sheesh. How to remove them though? Planks. They're here. Okay, so split. Let's split the planks. Boom. Planks. Let's see. Planks. What does it split if I split planks? Let's get a null. Hook it up to the other hooks. And we get this. But if we put it here, we get... What? What? Why are we getting this result? Then what are you splitting then? Invert selection? Huh? What? Why? What is this then? These are the planks, right? Okay, then let me do something. This thing is splitting planks prim. We don't need that anymore. Delete that shit. And this thing should just go back in here. Delete that shit. Then we should be able to have our points deform, unpack, merge. All right, what is the split here doing then? What is the split here doing? If I flip it. Annoying. I don't want those. How can I get rid of them? I really don't want them. They are so much geometry. I think this is why the thing is so slow. Vellum solver takes the thing now, the groups. These are the points, yeah. These are the planks. Then this thing goes right into the merge, and that is needed. So right after that merge, after it glued the points with the respective points of them as well, the question is, do we need... Yeah, we need them. Then when they go into a Vellum solver, and then we have lost completely all those groups, right? Is there planks here? Yeah, there's planks. That's at least good. Then we have our Vellum thing, transformation thingy. Okay, and then we have the unpack. But I feel like before they unpack, we need to get rid of them. So split. Here. And now let's split some stuff. Cut region. That is all it can do? Are you for real? Why? What? Why is it only taking the cut region here? What? Can I do the split before though? Can I do it on this side, the left side? Not this side. Oh, damn it. Left side? Is this the left side? This is the middle side. I don't want it on the middle side. Do it on the left side. Okay. Now, planks, get the hell out of here, man. What? Invert selection. What happens? Nothing. Null. What are you splitting, buddy? What are you doing? What are you actually doing? Okay, cool. Now invert that. Okay, so what are you splitting anyway? Nothing, right? You're just being an idiot, right? Why is it not showing anymore, the planks? Damn, man. This is harder than I thought. Why is it happening this way? Oh, wait. Group. Breakpoints. No. What type of group is the planks? This one. Points group. Should it be a points group though? Just changing it to primitives. Let's see what happens though. If we go to split here and I choose from there, nothing. Still nothing. It sucks. Why? Are we in the left side? Damn, man. Okay, Control Z, Control Z, Control Z, Control Z, Control Z. Yeah, change. Delete that. Yeah, I don't want the split at all. Take that out by split. Okay. What type? We only have cut region here. That is so weird, dude. Piece attributes. Can we take a group, call it planks, see what happens afterwards? Huh? Why is it only... Okay, it is showing everywhere. Can I make everything but not planks? What happens then? Nothing happens. Literally nothing happens. Damn. Unpack. Group. Nothing. No group. Transfer attributes v cut region. Damn. This is like... We can't delete it at all. We need its information though. We need it here to come with us. Alright, let me save that. Give me 5 minutes break. I'll be right back. This is mind-boggling, man. I think I get the problem. We'll just go now do the dirty work, basically again. So double click here on the sim again. And let's check the split that we've added here. That is a legit split. And we've split the planks. And that is basically should have been everything but the planks. But they are not updating. Maybe we change the name somehow. In here, no, the names are the same. Maybe the invert should be gone. And let's check what happens after. Okay, yeah, we don't need this way. Invert, no. Okay, planks. Nothing is happening. How do I get the thing away from here? How to get it away? Why is it not going away as well? That's also quite annoying. Where is this coming from? It's not there, guys. Like, where is it? Where did it go, dude? Solver, we haven't changed anything in here, and it's not visible. Split, where are you, man? Come on. Where are you at? What is this? Diagonal rope, lower rope, upper rail, vellum object. Nothing here. Nothing here. What is here? Is it there? Also not. Where's the planks then? Where are they at? Why are they not coming? Planks are here. Damn it. Then why is it not working? What is it saying? Distant, drag, tangent, up, normal. Oh man, planks are here. Do we have planks here too? Where is this going? Planks, where's my planks? Planks, here. And when they go in here, something is happening where our planks group is being processed to target the up and down rails. Fine enough. But then once this comes out, it doesn't come out as planks anymore. No planks here. Group nodes, mainstream, pins. Planks here, good. What do we have in here? Planks are here. Okay, then why are we not being able to see our planks in the upper version here? Go back. Invert of the boards, which is the invert of the planks. And this should make this work. And here the merge should have them away from here. What? What is happening? Object merge blast. So why are you still here though? Why are you still showing? I don't want you to be shown anymore. Who merged you in here? Okay, wait. Do I need to split this before it comes here though? Wait a second. Does it work like that? Does it still work? Oh, damn it. Pack. Split. What is this split doing anyway? And in the merge. It's so funny as we still see the planks. Why whatsoever? Why do we still see them? Why are they still visible, dude? Damn it. Can they just get the fuck out of here? It's really annoying. Breakpoints, edges. I mean, how does he have it? He has the split separated from this thing. Damn. Oh my god. So annoying that I'm still having this issue right now. I need to keep going. Yeah, it's like, can you just get out of my face for once? Dude. This is so unfair that I'm getting this now. I'm really salty right now. For him, it's over. Well, I need to watch this and follow it one by one. Must be missing something. This should be solving it. Should be quite simple. Like, I don't know what I've done here the whole time. Been trying to freaking fix this, but I need to remove the splits that I created. I hope they're not here anymore. Basically, this should have solved it. And now we've taken it from the blast, and because we've done so, we broke some things. Alright, let's see. Cut region. Let's take it from the plank, from the pack, sorry. Alright, so what we do is... Sucks. Let's do it. Pack, right? Where is it? Right there. And yeah, let's take our pack instead of the blast. Alright, here we go. Boom. This should fix it. We unpacked things. We still see the freaking things here. Why whatsoever? I really have no idea. Piece, good. Unpack, good. Split. Why is this split? What is it doing? Let's just delete this. And check our merge. Damn. Where are they coming from? Where are they coming from, dude? Okay, why is it not working? Yo. Just keep watching it. I'm gonna keep watching. Okay, so what we realized, I just stopped the recording because it took a bit long than usual. The problem was with the switches, I assume. So I deleted the switches. I went with one incremental save backwards. I deleted the switches here. We added a switch here and another switch here. because we wanted to separate things, blah, blah, blah. It still showed up when I've clicked the Vellum solver for some reason, but when I've baked the whole timeline and went into the, the Vellum pieces, transform pieces, it had been gone ever since. Good stuff. Finally, we have figured a solution for this. I think that's it for today, honestly, guys. It's getting late and nothing's running away. I will probably stream also tomorrow because we are still quite behind here. Yeah, we have still some minutes to watch in the Polish video.
Hello.
And we'll get that all hooked up tomorrow maybe, because I haven't streamed on Thursday anyway. So yeah, I'll take that back. As for now, thank you all for watching. I will be back tomorrow and we will continue where we left off. This has been fun so far. We've done some cool simulations, as you can see, and we learned some cool things about how things work, basically. Yeah, this is looking amazing. We will continue where we left off right tomorrow. Check the schedule just in case, so you know when I'll be streaming. I'll also try to figure out the multi-stream setup, so I am streaming almost everywhere for us, and reach more people to learn more stuff and more Houdini and more everything game art related things. Okay, guys, thank you all for joining. Those on the stream, if you haven't follow me. I will highly appreciate it. This is a 3 weeks old stream, and yeah, we've grown 40 followers. That means every week we're almost making 10 new followers. That is amazing progress. I'm pretty happy with it. If I keep this going in a year, I should be having almost 150 or 200 followers, and yeah, this will keep growing, that's for sure. On the YouTube, it's been growing exponentially, and I will still basically add more content, trying to get into TikTok and add more shorts, and yeah, see how that works with everything else. Thank you for watching. I appreciate you, and yeah, see you tomorrow. All right, stop recording and